Okay, so it's recording now. I will just
All right.
walk through the way she likes to work, and then we'll now address your
Okay.
file.
All right.
So, which project would be best to use? I think that would be okay. San Clemente. Yeah, I sent this file to you, right? I shared this file with
Yes.
you. Okay. So,
San Clemente,
starting
19.
with okay. So, um, most of the projects we work on tend to be additions, alterations, renovations, garage conversions,
Yeah.
ADU, attached or detached, or JDUs.
Yeah.
Okay. And typically, you want to have a code summary and project data, which shows the address and then all the applicable building codes for that jurisdiction.
Yeah.
But usually, you would have all the basic California codes, that's CBC, CPC, CRC, and all that.
Mm-hmm.
Sometimes you may have city specific codes or
Cool.
ordinances. Yes.
Yeah.
These ones are statewide. All the counties and
Yes.
cities in
Yes.
California has to comply with these
Yeah.
ones. But sometimes you also have city ordinances. For instance, the project we are looking at is in Mountain View. This is a city. Mountain View may
Yeah.
have, um, in fact, every city ideally should have either a city specific ordinance or county specific. Meaning, the
Yeah.
county consists of several cities. So sometimes the city
City.
may,
Yes.
may defer their ordinances to the county level, and some other times it may be
Yes.
at the city level, so that has to be indicated here. You also need to
Yeah.
specify
Yeah.
the construction type. For
Yeah.
most of the projects we are doing, they tend to be type VB, which is your timber, stucco, and all that. So this is a common construction
Mm-hmm.
method we'll be working with. Occupancy too is mainly residential, so R3 and U is for
Residential. Yeah.
residentials. Zoning changes between each city. Sometimes you have RM, sometimes you have RS, or some other one. So you're supposed to find out this information for every project you are
For
doing.
every
And
project.
yes,
Okay.
there are
Yeah.
publicly available data for that. Your APN number too, you can get this one from Redfin. So
Yes.
jurisdiction
I'm doing it.
jurisdiction is basically you are saying the you are specifying the authority that will review this plan. So yeah, you are saying it's the
All right.
city of Mountain View that will
Yeah.
review and provide their plan check comment. The existing
Yeah.
use, you are in the case where you are working on a renovation or addition or alteration, you need to tell us what the existing use of the building is. If it's a single family home, if it's sprinkled or non-sprinkled, or if it's a multi-family dwelling, that needs to be
Yeah.
stated here. You also need to tell
Yeah.
us the lot size. That can be obtained from
Yeah.
Redfin. Now you move on to the
Yeah.
area analysis, where you specify the existing floor
Square
areas,
footage.
or in square
Yeah.
footage, of course, and the proposed. So where you have an
Yeah.
addition, you have to specify that okay,
Yeah.
you know how to differentiate between an addition, alteration, and renovation, right?
Mm. Yes. Yes,
Okay,
I
let's say we had this layout for the existing. Um,
Yes.
if we are doing an addition, we are adding to the footprint of the existing. So meaning, let's say the client
Yeah.
wanted to add a living space, or let's say they wanted to add another bedroom here. In this case,
Yeah.
it will be an addition because you're adding to the existing footprint or floor area of the building. So
Yeah.
this area
Yes.
would be regarded as an addition, and
Addition.
yeah, we
Yes.
have a specific pattern we like to use for addition areas. Now,
Addition.
an
Okay.
alteration would be taking an existing space and altering its layout. So the footprint is not changing in the case
Yes.
of an alteration. Let's say we had this space to be a garage before, and now we are introducing an office
Yes.
space. We are introducing like a home office
Okay.
in that garage. Then
Yes.
that's an alteration because we are altering the footprint of the existing garage. We are altering the layout of the existing garage. The footprint
Yes.
remains the same. So in the case of an
Yes.
alteration, we like to use a single hatch pattern. And then you also have remodeling. In the case of remodeling, you are not significantly altering the layout, but what you are doing is you are upgrading the space. Either you are, changing the furniture, plumbing fixtures, appliances, and all that. In that case, what you are
Yes.
doing would be
Yes.
regarded as a remodeling project. Let's say you wanted to
Remodeling.
refurbish the kitchen space by changing the counter and appliances.
Yes.
Or let's say you wanted to replace all the windows in the house, the doors and windows, that would be regarded as a remodeling project. Now you could have an ADU. Now an ADU could either be an addition or an alteration,
Yes.
and the addition ADU
Okay.
could be attached or detached. So if you're having a detached ADU, it means maybe somewhere within the property you are building out another
Yes.
structure. That would be regarded
Yes.
as, you know, an a detached ADU. This will be
Yes.
independent from the main house. This will have its own electrical panel,
From
its
the
own
main house. Yes.
kitchen and everything,
Yeah.
and this will be occupied by another separate family unit. Another occupant will be here. So within
Yes.
the same property, you now have two different families occupying two different structures there. So that would be regarded an as a detached ADU. Now an attached ADU could be an addition. Let's say with this addition project we were this addition area. Now let's say we wanted to make it an ADU. This will be an attached
Yes.
ADU.
Ah, shit. Your screen has gone off. I can't see.
Wow.
Can you do something?
Is the network or I'm still sharing? Maybe you should try rejoining, or I don't know. Is the network?
I should log out and return, Abby.
Yes.
Abby?
Yeah, try that.
Okay. Just a second. Yeah. Let
Okay.
me start. Hello?
Yeah, I'm with you.
I can see your screen now.
Okay, great.
Yeah, I can see your screen.
So I was explaining that an ADU could be attached or detached. If it's detached, it means that you have a separate outlet
Yes.
somewhere on the property, where you're building the ADU. If it's attached, it means the ADU shares the same footprint with the rest of the house. But you could have two different
Yeah.
occupants, accessing both the main dwelling and the ADU. So you could have one family here, and then the main house, another family here. So
Yeah.
it's still regarded as an ADU. Now you have another
Yeah,
case.
they just.
Yes. Now you have
Okay.
another case where the ADU can be directly accessible from the main house. Let's say someone introduced a door here. That's also another peculiar case. Now this one will be
Yes.
regarded as a JADU. That's a joint
Yeah.
accessory
Yeah.
dwelling unit. So what
Yeah.
differentiates the ADU from the JADU is the accessibility from within the main house. That's the main
Yeah.
difference. So think of a situation where someone has their grandmom living with them. So they want to have some measure of
Yeah.
isolation, or should I say privacy, without completely
Privacy. Yeah.
excluding the grandmom. They want to still be able to access the granny
Yeah.
quarters. So that's why another term for ADUs could be granny flats. They also regard them as granny flat. So I've introduced the difference between an ADU and a JADU. A JADU must always be
Yeah.
attached to the main house. That's why it's a joint accessory dwelling unit. But an ADU may or may not be attached to the existing main house. And an ADU must not be directly connected with the main house. You cannot move from within the interior of the main house to an ADU. If you can do that, then it's no longer an ADU, then it's a JADU. And now you have garage conversions too. Like I explained here, you have an existing garage space and you are converting it into another use case. Maybe you wanted to have an additional office or a new bedroom or an ADU, anything you are, provided you are changing the function of that space from being a garage to something else, then what you are doing
Yeah.
is a garage
Yeah.
conversion. And it's increasingly common because
Conversion.
most people are trying to make more money with their houses. So what they tend to do is convert the garage into an ADU, so they can make extra money from that. Now, the essence of differentiating all these things is because you need to document. Um, you need to analyze the areas, right? And you need to comply with some
Yeah.
requirements. And you also need to be able to. There are requirements when you have separate units within the same building footprint. In some cases, in fact, in all cases, where you have separate occupants, you need to be able to design a 1 hour fire rated wall as or you also
Fire.
yeah you also regard this as the
Yeah.
demising wall. This is a demising wall, and the requirement is to have it to be 1 hour fire rated and at least 50 STC. That's greater than or equal to 50 STC. I will share a website where all these details can be
Yeah.
obtained. But what you should know is, in the case where you have two different occupants within the same building footprint, that wall that separates both
Yeah.
units must be at least 1 hour
Yeah.
fire rated and 50 STC. STC is sound transmission control. So it's basically a way of
Yeah.
achieving sound isolation between both units.
Um. Yeah.
So bear this in mind. In the case of a garage, you need a 1 hour fire rated wall, but you don't need the sound isolation because it's assumed it's the same occupant that uses the garage and the existing main house. So you don't need the 50 STC. But in the case where you have maybe an ADU or another occupant
Yeah.
and then there's
Yeah.
a separating wall, then you must have both the 1 hour fire rated demising wall and the 50 STC. So when you're doing your area analysis, you need to tell us all the different units available in the house. If you had an ADU, you have two different sections. Main
Yeah.
house will be one section. ADU would be another section. Now
Maybe another thing.
under the main house, you're going to break down all
Wait,
the areas.
wait, are we on record? Are we on record? Huh?
Sorry, yes, we are. The
Hello?
call is being recorded. Yes.
Oh, okay, okay, I'm with you.
Okay. So after specifying the section you are analyzing, you now need to tell what the existing living space or living area is, what the garage is. If you have any space to remove, you must tell us what the area of that space is. In this case, we are demolishing the sunroom and we are adding a rear addition to
Yeah.
the sunroom. We are adding 65 square foot to the sunroom, which was previously 261.11. So that has to, you now have to give us a sum to know what the new rear addition would be. Now we are also converting, we are also converting, partially converting the garage. Meaning, what we did was we took that full garage space. Let me show you the floor plan. This was the garage. It's a two-car garage that previously existed. So we took that garage
Yeah.
and we divided it into two. So we reduced it to a one-car garage, and then the other half we converted it into an office space. In fact, two office spaces. So that's why you see us using this kind of terminology. This
Yeah.
where's my cover page? That's why you see us saying we are partially converting the garage, because there's still a one car garage in the eventual conversion, but
Yeah. Yeah.
we still had to, provide an office space in it, and then we specify the garage to remain. Now, after breaking down all the areas, you are not supposed to go ahead to tell us what the total conditioned area would be. The conditioned space, as the name implies, the part of your house that would need to be that you need to provide HVAC for, basically your heating, ventilation, and AC. You need to, you're not ventilating, you're not providing HVAC for all the spaces in the house. You don't need to provide you don't need to provide HVAC for your garage or your closet.
Yeah.
No, you need to provide HVAC for your closet, but you don't need to provide underfloor heating
For garage.
for your closet and your garage too.
Mm-hmm.
So your total conditioned area will exclude those spaces that you are not providing HVAC for. Now, because we have an office space in the garage, so we had to add that
Yes.
area for the new office to the conditioned area. But
For the office.
yes, note that we excluded the garage to remain from total conditioned area. So you quote the value in square foot,
Yes.
and you also now need to tell us the what we call the lot coverage. That's another term for this. In fact, that's why I ought to have noted here. What we are calculating here is essentially the lot coverage. So three
Okay.
there are three similar terminologies for coverage calculation. You have FAR, your floor area ratio, you have your lot coverage, and then you have your site coverage. And I will explain what they all mean. The lot coverage has to do with just the first floor, right? The main living spaces on the first floor divided by your lot size. That's the size of your lot times 100%. So that gives you the percentage lot coverage. Now the FAR, which is your floor area ratio, will be the total sum of all the spaces, all the living spaces rather, including if you have a second story, divided by divided by the lot size times 100%. That gives you your FAR.
100%.
Yes. So note the difference between lot coverage and FAR is that lot coverage factors the garage, right? It includes all the, it's like the basic
Yeah.
footprint of the building divided by the size of the lot
Mm.
times 100%. That's your lot coverage. Now your FAR is the total living spaces. So you are not going to add the garage because it's not a living space.
Garage.
It's for vehicles, not humans. So you are going to exclude the garage.
Yeah.
And if you have a second story, you are going to add the floor area of the second story to your FAR. So you sum those areas and divide by the size of your lot. Then times 100%. Usually we want to keep this value to below, I think, 44 or 45%. So once you have a value that is below 44 or 45%, then you've complied. So those and then the last one I mentioned, site coverage. Site coverage is basically
Yeah. Yeah.
all the areas plus your pavement on the site, any hardscaping you have on the site, you are going to include
Mm-hmm.
the area of your hardscaping and then divide by the size of the lot. Now, the significance of all these values is just to keep density of occupation to below 45%. You don't want to make sure the development is too dense or too congested.
Yeah.
So,
Including on the site. Understand?
yes. Now, you need to also specify your scope of work. This is basically a written description of all the changes and improvements you are doing to the property with this your proposal. Excuse me. So now you can see on
Yeah.
this scope of work we are specifying that we want to demolish the existing sunroom and want to provide a new dining room. We want to remove the existing windows and replace with a folding patio door. Somewhere at the back, we are going to be removing the windows and
Yeah.
adding a patio door. Patio door is just your either sliding or folding door that opens onto
Yeah.
a patio. And then you also here we are also removing the existing sliding doors and replacing with new windows. We are upgrading the electrical main panel to 200 amps, and then we are partially converting the existing garage into an office space. Now the electrical panel is okay. We are still coming to electrical plans. Remind me to
Mm-hmm.
talk more on electrical panel. Now, most of these general notes, electrical notes, and plumbing notes are generic. These ones you see here.
Okay.
Whenever you are doing a project that has any electrical aspects to it, you have to
Yeah.
include this plumbing. You have to include
You
this
take it.
general notes. You have to include this vicinity map. Tells us how you access the site. Is what we call location map here. So usually you
Location
can
map, yeah.
you can just screenshot from Google Maps. Just make sure the area you are screenshotting shows the basic outline of the building. You know, if you zoom out too much, you will not see the outline of
You not see
the
yes, I
building.
know.
So zoom in such that you are able to see the outline of the building, but not too close. Then you can screenshot that, save that, and then
So that I can see
yes, add
access
to
routes.
your Revit file. But make sure you do a sketch of the outline. You point at the site, and then you show your north arrow. So all the other ones,
Yeah.
you need to specify the project owner, the designer, structural engineer, MEP engineer, any other consultant. If you have an arborist, you state that here.
Yeah.
So that's for the basic project data. Now, moving on to existing and demolition site plan. On that's a site plan that shows the features to be demolished from your house. So if you have any pavement and you are demolishing that pavement in order to create allowance for your addition, that will be shown. And then on your proposed site plan, you have to show the the finished state of the project, right? You are telling us that okay, after all the improvements and additions and everything,
Final,
this is the outcome of
this is how it is.
yes the project. Now, you would already be familiar with phase filters and all the settings and how to tweak
Yeah,
them in order to
yeah, yeah,
achieve these graphics.
yeah,
So for the purpose
yeah,
of others, this is a recorded call. Let me just brush through it. So
yeah, yeah.
what we have to do if we are showing an existing and demolition plan, it could be a site plan, it could be a floor plan, it could be an elevation. But whenever you are trying to show an existing and demolition drawing, what you have to do is go to the phase filter, set it to show previous plus demo, and then go to the phase and set it to new construction. Once you do this, your graphic would change to reflect the elements that are being demolished. But of course, each element in Revit has an associated phase, right? So it has a phase created and a phase demolished. Anything that exists, right? If you, in the case of
Yeah.
renovation, addition, or conversion, there has to be something that exists. So your walls, your floors, your roof, any element of the project that exists will have a phase created to be existing. Now, if that element will be demolished, then its phase demolished will be changed to new construction. But if that element will not be demolished, its phase demolished will be none, right? So that means
No,
that
no, yeah,
that element will be
yeah,
retained. But for this project, we want to demolish
yeah,
this pavement. So that's why we are marking its phase demolished to new construction. And on your site plan, you need to show things like property lines, you need to show the dimensions, although that wasn't shown here. Let me see if I have another site plan open. Okay, this is another project entirely. So this is what a proper site plan should look like. But this is one you're working on, Ife. So um, the
yeah,
site plan should show the dimensions of the property line. You must show that. Usually, I have a separate dimension string that I use for the outline.
okay,
So I've renamed it to big site. So that's what you should use for showing the dimensions of the property line itself. But every other dimension on the site
the
should be a
property.
regular linear 3 over 32 inch area.
Uh-huh.
So
No, but 32 inch
yeah,
area,
every other
yeah,
one. But the main outline should be shown with this one I named big site. Now you need to
inside,
show you need
yeah,
to show the center line of the street. Ideally, this is a cul-de-sac. The way this project is,
yeah,
it's if you check the address on Google Maps, you will see that it's a cul-de-sac. So ideally, if you were not dealing with
yeah,
a cul-de-sac, this center line should be along the center of the road. What do I mean?
yeah,
Um, Let me show you on Google. Let me show you with another project here. Um,
um, click on,
yes,
click on, hello?
yes, I'm with you.
Okay, okay, don't worry, I was struggling to hear you the other side, I hear you now,
Okay.
yeah, okay,
So,
yeah,
in the case where you have a linear street like this, the center line shown should be at the
yeah,
center of the road, not along the edge.
the
And
road,
yeah, if you have a name
okay,
for that street, you would indicate the name. For the case of this project, the street is Current Street, so that was shown. This CL just tells us that line you are seeing is the center line, and then you have an asphalt road, so that has to be stated too. Now this symbol is PL. It's just you are telling us this is your property line. So this symbol you see here
yeah,
should be copied along the property line. Now, if you want to go ahead, you could also have another full text description to tell us it's a property line. And this site has two adjacent roads. You have the Current Street and the Grimmer Boulevard. So that's what we've shown here. So this is Grimmer Boulevard, and that's why you see another street there. and of course you must show the center line for the street, the finishing, the kind of street it is. If you have an asphalt road, you have to state that here, and then the center line. So you must show other features on the site. If you have your hardscaping, your pole, your trees and everything, those must be shown. And then you must show the driveway, you must show the material, you must show the direction of slope, right? I don't know why that wasn't shown here. Let me go to another project. Your direction of slope is usually 2% away from the building. Right? You must slope 2% away from the building. Why don't I have that here? Strange. But just bear that in mind. You need to show the slope of the site. That's let me just yes. This is how we typically represent it. You just draw a text and type 2% slope. Now there are codes for the slope. In the case of your hardscape, it will be 2% away. In the case of your soft scape, it will be 5% away. I don't know if you understand that. So this is 2% because we are dealing with the hardscape. So you just show 2% slope directions on the hardscape. By hardscape, of course, you know I'm referring to your pavings and any other construction on site. Now, your softscape would be, your lawn, your gardens and any other feature of the site like that. So usually you will be sloping 5% on such areas. So this is what I mean. Let me show you another project where I did the grading. So this process of specifying the slope away from the building is also known as grading, because usually when you build, you want to have some slope on the site for runoff. Usually you could choose to manage runoff within the site, or you slope runoff towards the street. You have manholes and other drainage channels. So the essence of grading is to allow that runoff to flow towards the street. So on this project, you can see we already showed the direction of slope, and you can see it's usually away from the building and towards the street. So other elements you may need to show on your site plan will be your sewer cleanout or connection point. Your sewer cleanout is let me show you a sample one. It's just a point where you connect your sewer to your main sewer line. So if you look at a section through the project, you can see that there is the public sewer main, and then you have your sanitary pipe from the building, and then you have your lateral. This thing is called the lateral that flows from your building towards the main. That section of pipe that connects the building to the main is called your lateral, and it has clean out, which provides access for maintenance. This is what it looks like on the site. It's like manholes basically, but in the case of small residential projects like this, we just call them clean out. Now clean out have principles for how they should be positioned. If we have the time to go through plumbing, I will talk more on that, but just know that on your site plan you need to show us the location of the clean out where you have that information. But if you don't have the information, then don't show it. Now your gas meter needs to be indicated too, your electrical meter needs to be indicated, your water meter needs to be indicated, your air conditioner in the case where you have an outdoor unit. In fact, you always have an outdoor unit. Needs to be shown too.
Mm.
You need to show now the grading information. In addition to showing slope directions, you also need to show. You need to specify that the finished grade will slope 2% away from the building foundation for at least 5 feet. But this is in the case of your hardscape. Now you can go further to say for subscape, it's going to slope 5% away. You can see on the subscape we've shown 5% away from for the building. This is your softscape, but your hardscape we've shown 2% away. Yeah, and that's usually directed away from the building, not towards the building, because you don't want flow to be towards your foundation. You want it to be away from your foundation and towards the street. So that's the concept. So you need to also point out all the other panels, your electrical panel. If you have a solar panel, by solar panel I don't mean the ones that we put on the roof, or you could say solar circuit panel. That's where it's like your distribution board sort of, where you separate the main to all the circuits in the house. I will explain that. But this solar panel they are pointing at is not the solar panel that goes on the roof. It's your solar circuit panel, and then you have your electrical circuit panel. This is the one that is connected to the grid. This is one that is connected to your solar panels, your normal solar panels. So now this is a solar circuit panel. Now you need to point out your air conditioning. If you have an outdoor unit, you would show that here. But now this note you see here is specific to this project. Here we are providing two separate electrical meter panels and two separate water meters, one for the main house and the other for the ADU. For this project you're looking at, there's a detached ADU, which is attached, sorry, because we have the existing detached garage. So we are attaching the ADU to the detached garage. You can see there's an existing garage in the house that is not attached to the existing main house. So now we are adding an ADU that is attached to that garage. And from what I explained about firewalls, what would be your understanding of this separating wall? It means that we have to provide a 1 hour fire rated wall here, but we don't but we don't need 50 STC here, because this garage is not being occupied by a family. So now sometimes you have your building outline or your footprint to be less than 5 feet from the property line. In such cases, you must also provide 1 hour fire rated walls along those walls that are below 5 feet from the property line. So here we have this wall that is 4 feet from the property line. So the code requires us to provide a 1 hour fire rated eave, because that eave is already too close to the property line. But you see this other wall, this other wall, we are 8 feet 6.5 inches from the property line. So we do not need to provide a 1 hour fire rated wall here, because we are above 5 feet from the property line. And likewise here, in some cases you may have your building to be okay. Let me share this image with you on WhatsApp. So
Okay.
hello.
I deal with you. I dey check am out. You can read it.
Mm.
Yeah.
So now I want to explain that sometimes when you have a detached structure from your existing main house like this, let's say we had the existing main house to be here, somewhere around here. Let's say this was the existing main house, and when you check the dimension, you saw that this distance is less than I think it's usually like 6 feet. If it's less than 6 feet, then this wall must be 1 hour
Okay.
fire rated.
Okay.
This wall must be 1 hour fire rated because now you have your new structure to be less than 6 feet from the existing house. You know, because of that proximity, you need to provide some kind of fire protection for that wall. But it being that distance exceeded
Yes.
6 feet, then you don't need to provide
6 feet.
1 hour fire rated walls here. So bear that in mind. And if you have a fire rated wall, this is how I like to show it. There are different approaches. You can specify the detail on another sheet and then just point at that element and tell us the sheet and the detail number where to find the detail, and you can just provide a
No,
text that
family.
says provide 1 hour fire rated if. Another approach I use sometimes, which I also used on this project, is to have a legend. So somewhere on your legend, you would draw the wall and draw, a line beside it. Give a color to that line,
Yeah.
and then you specify the construction of the fire rated wall. So in this case, how we achieve 1 hour fire rated walls is we have 2 layers of 5/8 gypsum boards, usually type X, or sometimes they call this sheetrock, and then
But
you should extend.
wait, can you repeat? This detail, the fire rating, I'm not finding it in my own drawing.
Yeah,
What drawing is it?
this is another project. I've not shared this file with you, but don't worry, I'll provide everything.
Okay.
But
Okay, not in this sheet. Okay.
no, it's not
problem.
the
I'm just
but
trying
the
to-
project.
But I'm checking along as well.
Okay, the project you are working on, you don't need to deal with any fire rated words. But
I mean,
I'm explaining everything from the very fundamentals. So if you have to deal with projects where you have to provide fire rated words,
So that
you
project,
should know
yeah.
what to do.
I
So
will.
basically, this is there are many approaches for achieving 1 hour fire rated walls, but usually this is what we use: 5/8 gypsum boards. Your normal gypsum boards are 1/2 inch thick, but where you have fire rated gypsums, you could have 1 layer, 2 layers. In this our project, we're using 2 layers of 5/8, and it's type X, is like sheetrock, and then it should extend from the bottom of the deck above to the foundation. So that's how you protect your walls. And then on your floor plan, you now show that line. So basically, this line and this line you see beside the wall is referring to this legend. So anybody reading this plan understands that this wall section has to be 1 hour fire rated. So that's the principle. Um, so back to the project we're looking at, which is this. So by the time you have all those information going on your site plan, you already have a detailed site plan. Yes, setbacks. You need to show us allowable setback lines, which you would obtain from your ordinances. I will still share information on how to research any ordinance of any city in Cali, but basically, when you obtain that information, you need to show a line or some kind of outline that depicts the allowable setback. Usually you have like
Allowable setback.
you have like 5 feet from the side property lines and 20 feet from the front. You have like 20, 25 feet, 15 feet, depending on the city, from the back. So
Yeah.
sometimes you can be allowed to encroach into your setback lines for various reasons, but that requires the city to, see whether you deserve the encroachment permit. That process of being allowed to encroach is called an encroachment permit. It could be relative to your setback, or relative to your easement. You also have easement to bother about. I did a
Yeah.
project that involves easement, so I will just show you. That project is on AutoCAD, so that's why I'm loading up my AutoCAD. So I think it's Elderwood. Yes, it should be this one. So on the site plan for this project, we we had to depict the easement. The easement basically would be like the area of the site where you are not allowed to do any kind of development because you have service lines going through those spaces.
Yeah.
It could be for communication lines, it could be for drainage pipes, it could be for some other public use. So those kinds of areas on your site, they have different kinds of easement or terminologies they use for them. They could be public service easement, they could be storm drain easement. Those are the two common ones, and they vary in widths.
Okay.
And sometimes you may be lucky that there are no easements on your site. In such cases, you don't need to depict them. But in cases where your site has easement, you must show using any hatch pattern of your choice the width of the easement.
Yeah.
And so if we have easement like this on the side, then under no circumstances should I now build maybe my garage into the easement. That's already an encroachment, and it may or may not be permitted. There was a project we did where we had the wall flushing directly with the easement, but then the overhang now extended by 1 foot into the easement. You understand? If the wall itself
Okay.
flushes with
Yeah.
the
Yeah.
easement, the roof overhang
Not.
will extend by maybe 1 foot or whatever your overhang is. The city had to now tell us to go
Yeah.
and remove the overhang and terminate the roof directly at the wall boundary because they did not allow us encroach
Yeah.
by even 1 foot into the easement. So that's why before you do any kind of design, addition, alteration, or whatever, you need to research into the setbacks and easement so you will not go and design and then later you discover you've encroached into the easement.
It's not
That's
permitted.
like wasted manpower. So that's on easement. So that has to be shown on the site where you have easement. Sometimes they require you to identify the species of the trees available on the site. So that you infer from your Google Maps. If you can identify the trees, you do so. If you can't, then you have to work with a project arborist who will go on the site and do some checks. But basically, if
Yeah.
you can identify the trees, you tell us the species, and then you tell us the diameter at breast height. That's the meaning of this DBH. So you do that for all the trees you can spot on the site. You know, just be very generous with information. The core of your project is to add as many information as you have onto the drawings, because if you don't do that, then the city will be sending back the drawing to ask you for those specific things. So
Information.
I believe now the rest will now be graphical, you know, aspect. For instance, you want to identify which one is the main residence, which one is the garage, which one is the sunroom. Like you want to identify the area of work. Most of the work we are doing in this project are towards the rear, so we are showing this thickened outline around the area of work, and we are tagging it to be area of work. Those dimensions from the building corners to the property line, we are showing the dimensions, and we are identifying them to be setbacks. So you must add the text. This is a setback, rear setback. In some other cases, we would want to show the addresses of the adjacent properties. In the case of this project, we are showing the addresses of the properties to either side of the building, and that can be obtained from Google Maps. So that's for the site plans. Then Existing and demolition floor plan. On this, you are showing the existing and demolition, do I say, aspects or information of your project. So you are showing the existing conditions, right? The walls, the floors, the roofs,
Yeah.
all the elements that already exist need to be represented here. In addition to that, you're also showing elements to be demolished. You know, if you have a door that you want to demolish, you must show it as an element to be demolished. And if you recall from my explanation earlier, I said if you have an element that you want to demolish, you select it. The phase created will be existing, and phase demolished will be new
Yeah.
construction. So that applies to
No, construction,
every single model element on your project. And then that view that you want to show as existing and demolition drawing or floor plan
Yeah.
or site plan or elevations, this is the setting to use. The phase filter would be show previous plus demo, and the phase would be new construction.
New
So
construction.
so where you have show previous plus demo and new construction, that means you are trying to show us the existing and demolition floor plan or site plan or elevations. But make sure you always name or rename every view, right? Make sure you always name and rename every view. For the SLC method, sorry I didn't mention earlier, this approach to working is, just think of it as SLC method. Now there is the Kai method. I would, if you ever have to work on Kai projects, I will explain the Kai method. But think of this as the SLC method, and she has her own, you know, graphical, should I say, requirements. She has a way she likes to present drawings. For instance, she likes to use lowercase to name views. I don't know if you've noticed, I have the views named in lowercase. This is the SLC method. We like to have views named in lowercase, and we like to have view titles towards the left of the viewport, bottom left of the viewport, and we like to have not arrow towards the bottom right of the viewport. So this is the SLC method. Now we have a way we like to show dimension lines in the SLC method. This is, you study the files I shared to you, you'll notice a pattern with how we show dimension lines. It's not the typical into in. It's exterior to in to exterior to in. So study the plans to understand the dimension pattern. You know, for windows, for instance, we like to show window end to the nearest interior wall. Window end to the nearest interior wall. For windows, in addition to using window tags, we like to show, we have a shorthand for how we like to, you know, show window information on the floor plan. So this window is a normal 72 inches by 34 inches sliding window. So the shorthand is to have a box text that shows the width by the height.
Yes.
And then you have this, you have this H semicolon and then another distance. This shows the sill height. This is not the height of the window itself. The width and the height of the window will be quoted in a box text in inches. Now the sill height will be the height from the floor level to the sill of the window. For the sake of others who may be looking at this video, let me explain what I mean by window sill height. Window sill height. So that's the height from, which picture explains it well? That's your height from the floor level to the bottom of the window. That's your window sill height. You know, look at this. So from your floor to the bottom of the window is your window sill height. So that information is shown here. H, lowercase h gives this. And now this other text that shows egress tells us that that window complies with egress requirement. And I will explain what egress requirement is. Every residential project in California has to comply with egress requirement, meaning every
Okay.
living space, every bedroom, right, has to have an
Yeah.
escape route in the case of a fire emergency. And if your escape route is going to be a window, that window must comply with certain requirements, you know. And in such a case,
Yeah.
you have an egress requirement. So these are the guidelines. The sill height must be a maximum of 44 inches from your floor level. You can see it here. The clear height is 44 inches from floor level. So if you have a window that is maybe 60 inches from your finished floor, such a window can never be regarded as an egress compliant window
Impression.
because the sill height already exceeds the maximum specified sill height, right? In addition to having the sill height
Yeah.
kept to a maximum of 44 inches, the window clear openable area must be at least 5.7 square foot. So if you have a window that is fixed, such a window cannot be egress. It cannot be egress compliant because that window is not operable. You cannot open a fixed window. Everything is fixed.
Yeah.
So if you have a sliding window, such a window has an effective openable area of half the window opening area. Do you understand? Because it means that a sliding window
Yeah.
can only open half of the clear area at any point in time.
Half of the yeah.
So that half area must be at least 5.7 square foot. Otherwise, that window is not egress compliant. Now, the best windows for egress are your casement windows because you can maximize the openable area in the casement window. You can open both panes and then the entire area of the window is open. So casement presents
Open.
the best egress windows. So now when you see us using a shorthand and we are typing egress beside a window, it means that that window complies with egress requirement. Some other times we also like to show the operation of the window. If it's sliding, you write sliding here. If it's casement, you write casement here. If it's fixed, you have fixed here. If it's single hung, you write single hung here. If it's double hung, you write double hung here, and so on. And there are also shorthands for that. So if you don't want to type it in full, casement will be CS,
Yeah.
fixed will be FX, sliding will be SL, single hung will be SH, double hung will be DH. You know, we also use those shorthands for Windows. Now, that applies to every other window on the project. You can see we have the tags and everything on every window. Yeah, we even had the operation of the window shown. We are telling us this window is a fixed window. So if you ever hear the term operation of a window, you are telling us how the window operates. Is it sliding? Is it fixed? Is it a casement? Is it a louvert? Is it single hung? Is it double hung? When you hear single hung, it's the kind of window that slides vertically. Only one pane slides. That's for a single hung window. It looks like this. So yes, thank God for this image. So a single hung has only one of the
Okay.
panes sliding vertically, but a double hung has both
Okay.
planes sliding vertically. So that's,
Sliding.
yeah, both of them are able to slide vertically. So that's a double hung
Okay.
window. A single hung has only one of the panes sliding vertically. Um, so now another aspect to the plans. Think of the plans as the most important drawing on any project.
Area. Yeah.
It's the most important because it
Yeah.
shows most of the information you need for your project. So we'll be spending quite some time on the floor plans.
The
Now,
plan.
yeah, another thing we like to show on the floor plan would be shorthand for the dimension of the space, and then for the ceiling height. All of these things have meanings. Now, this tells us the
Okay.
width of the space, the clear width of the space. So let's do a dimension to ascertain that. So you can see this should ideally be 10 feet 3 inches roughly.
10 feet one.
Yeah, I typed 10 feet 1, but the actual dimension is showing 10 feet
Okay.
3. So for the other axis, it's 10 feet 10 and not 10 feet 7. But basically, the dimension is going to show the width times or by the height. So that's what we are trying to
Okay.
show underneath here. Now, in any aspect of the project, wherever you see E in bracket, we are referring to existing. So whenever you see N in bracket, we are referring to
That's new.
new. So it's also a
New.
shorthand.
Okay.
E in brackets is existing, N in brackets is new. Now, when you
New.
see a boxed text directly underneath the space name, that box text is telling us the ceiling height of the space. That's from your finished
Okay.
floor level to the ceiling surface. Excuse me. That's referred to as the ceiling height of the space. Now, the E in bracket that is just
Yeah.
next to this box text, that is also underneath
Yeah.
the space name, is telling us that ceiling is existing. That's what this E beside the box text is telling us. That the ceiling that is, there's some background noise there.
I didn't get that.
I said there's some background noise there.
Hello?
There seems to be some
Yeah,
background
I
noise.
came out to quickly get something.
Okay.
I came out to quickly get something. I'm going back in now.
Okay. So the E in brackets beside the box dot is
Yes.
specifying that that ceiling is
Okay.
existing. So that applies to all the other spaces.
Existing.
Yes. Now
Spaces. Yes. I
now
get.
when you have box text indoors like this, you are telling us the width and the height of the door. Most doors are 80 inches tall. So the
Yes.
width could be 30 inches, 28
Okay.
inches, 36 inches, 26 inches. The width varies. Just make sure every door. In fact, I like to use the super door. So when you are looking for a door to use for the
Okay.
spaces, use the super door type. And
Okay.
that the dimensions have already been shown. So just select it. But make sure that any element you are drawing on the existing plan has a face created to be existing because that element is
So for the
existing.
existing.
So
Yes.
for your doors, you show the dimensions in box text. Now,
Yes.
another thing, if you have a skylight, you have to show the outline of the skylight where it is on the project, and you have to, specify that it's a flat profile skylight or whatever kind of skylight you have.
Okay.
So
Skylight it is. Alright.
when you show all that information, now attic access. Attic access is an opening in your ceiling that allows you access the attic space for maintenance or other kinds of work,
Okay.
maybe for installation or whatever.
I think yes.
Yeah. So that's your attic access. Now you have to show that information on your site, like your sink, your gas range, your refrigerator, your island, the dimensions. You know, I like to use generic
Yes.
model to model out these things. So if I share you a file, you're supposed to study the file to understand how I like to represent all these things. So look at all the
Those
details,
things.
the outlines, where and how the gas is
Yes.
positioned, dashed lines that shows the
Yeah.
thickness of the plywood beneath the countertop. So that
Yeah.
information has to be
Yeah.
shown. Now, when you've done all the basics, shown the dimensions, shown your elevation tags, shown everything, your doors, you now need to point at some elements. Now, on the sheet note, you can see things
Okay.
like remove existing doors, shown dash, and infill with new wall. So you are going to point at windows. Any window you have that you want to remove an existing, I'm sorry, if you have a door that you want to remove and provide
I want to
infill,
remove them.
not just to remove but to also build a wall to cover that existing opening. That's what we mean by infill with new wall and align to
New
match
wall.
existing. Then such a door would be regarded as you point A to such a door. What I mean is, let's say for existing we had a door like this, right?
Yeah.
Let's say we had a door like this. Now, if we want to demolish this door, if we wanted to demolish this door and then provide a new wall construction to cover up that opening, right? And fill the space and finish that wall surface with the same material you have here. Such a wall will be regarded as a an infill wall. Such a wall will be regarded as an infill wall. And if you have such a door in your project, you are going to mark it as E.
A.
Yes, so do we go over the plans to see such doors? So we have this double door to be
Yeah,
demolished
yeah, I can
and
see
then to be
70 by yeah.
you are now going to build a wall to cover up this opening. Now Revit, once you remove, once you go to phase created, existing, phase demolished to be new, Revit automatically provides the wall infill. You don't need to do it manually.
Yeah.
So note B says remove existing windows shown dashed. So any window you are removing, point B at it. So we are removing this window, we are removing this window, this one, this one. Just point B at any window you're removing.
Yeah, I mean,
Note
yeah.
C says cut opening through wall for new door. So when you have a door, or when you have a wall that you are now cutting an opening through that wall for a new door, such an opening will be regarded as C, cut opening through wall for new door. Then note D
A
says
new door, yeah.
existing water heater to remain. So you're telling us that this water heater, we are
Remain.
not removing it. Note C says existing skylight to remain. So this existing skylight, you
Remain.
are not demolishing it. So one thing you should notice, excuse me, this is not all the possible
Sheet
removal
notes.
or sheet notes you can have for
Yeah. I
existing
get
and demolition. Sometimes maybe you want to remove your kitchen cabinetry, there's another sheet note for it. So whenever you want to remove something and you don't have the sheet note, you can just slide into my DM. I will provide a more comprehensive sheet notes for you to use. This is a step. The garage floor level is usually at a distance from the existing main house floor level.
yeah.
I'll show you a sketch. This is your garage floor finish. Then you have your wall, and then you have your suspended floor, right? This
I don't have to
is
know that.
this is your floor
Huh?
level.
I mean,
Hello, Ife.
I'm gonna do. I'm with you. I'm eating this food.
Okay. So usually you have your garage to be at a distance from your garage floor to be at a distance from your main house floor. Usually your garage floor will always be slab on grade.
Yeah.
Or your main house
This 4 inch
floor,
slab.
yeah,
This
usually
4 inch slab.
4 inch, yes.
Okay.
Usually 4 inch. Now your, what's it called? Your main house floor can either be slab on grade or what do you call it? Your suspended floor.
Immaculate.
Now one can be like maybe 8 inches. So this is your suspended timber floor. Now you have a crawl space between that directly underneath your suspended floor. If you have a slab on grade, you don't have a crawl space. You only have a crawl space when you have a suspended timber floor. So that's your crawl space. And it's usually, I don't know if you're here.
I know with you.
Okay. So your crawl space is like earth surface that is like an accessible part of the just beneath the floor. It's a space beneath the floor, right?
What's the height? What the height you always use?
18 inches. 18 inches.
Can you hear me?
I can hear you.
I mean for the cross space.
Yeah, the crawl space is usually like 18 inches. 18, I've indicated it here, 18
Okay.
inches. Look at it.
Okay.
So all of this is earth.
Okay.
Now the crawl
Please,
space,
you send me this image.
of course I would. Now the crawl space provides access for maintenance. You know, if someone wants to go and maintain a plumbing line here, they can crawl. That's why it's called the crawl space. They can crawl underneath the
Yeah.
floor to
The
go
cross
and
space.
do their maintenance. Now, in the case of a garage, this would usually be like a step. You understand? This is the garage. If this is a garage space, this is a step that leads to the main
Yeah.
house level. So usually what I like to do is to have this garage floor to be 1 inch above grade. That's how I like to set the
Okay.
height. 1 inch above your finished grade level.
Above the grade.
But the main
Yeah.
floor level would be directly on the main house level or your first floor level. Now,
Yeah.
where you have a crawl space, you must provide for two things, and I will explain them.
Okay.
You must provide for crawl access. Whenever you have a crawl space, you must provide crawl
Call access.
access. And secondly, you must provide, can you guess the other one? You must provide
Another than that,
floor vents.
and the access double as good.
No. Access is for a human to be able to enter the crawl. So it's going to be covered after the human has accessed the place. But the underfloor vents are permanent, right?
Okay.
It's meant to prevent moisture buildup, rodent access,
Okay.
termites, and all these other things that are undesirable. I'm going to explain how you calculate the underfloor vent much later. When I'm explaining ventilation, I will explain how to calculate active vent and underfloor vent. But for the purpose of crawl space, let me see, this project, does it have a crawl space? Yes. Crawl access. So there's a crawl access, which is, so if someone enters this bedroom closet, right, they take all the clothes and everything out, and then there's an opening in the floor, they open it, and then the person goes, directly underneath the floor. through the crawl access. Hello?
I'm with you. I'm with you. Don't worry. I'm with you. I'm listening.
Now
Call up.
you have your attic access, which is the
Yeah.
reverse of the crawl access.
Okay.
The attic access allows you to access the ceiling. Let me see if I
That's good.
can
Yeah.
see if I can do a sketch for that one. So the attic access allows you access the attic space. So let's say you had this wall,
Yeah.
and then you had this floor, and then you had this roof, and now you had this ceiling here. Of course, you know that this is the attic space.
Yeah.
This is the attic space. Now you have
Yeah.
an attic access, right?
You
There are
see.
requirements for how you size it and where you locate it. I will go over the requirements. Now, what you should note is this attic access allows you to open an opening in the ceiling and go into the ceiling for different reasons, for maintenance and other purposes. Maybe you want to install your HVAC systems. Maybe you want to. There are many things you could have to do in the attic. So in such a case, you need to provide an attic access. Some other persons may have like a ladder system that can be dropped down whenever they want to access the attic. So the minimum requirement I think is usually 22 inches by 30 inches minimum. So any attic access you are designing must have a minimum of 22 inches by 30 inches per CRC 2022
Okay.
attic access. Now the code also says where you are positioning your attic access, you need a minimum of 30 inches headroom. 30 inches
30 inches
headroom.
That's 2 feet 6 minimum.
Yes.
Okay.
So the essence of that may seem obvious to you. Is that if someone is entering here, there should be enough space where they can put their head and enter the attic space. So that must be a minimum of 30 inches. So you can't just throw your attic access just anywhere. Maybe someone puts it at this very edge. If you check a section through it, there may not be enough headroom in that space. So you need to be able to look at your section. Yes. Yes, you need to be able to look at your section to determine the best possible location for your attic access. Usually we like to put them in hallways, and if you don't have that allowance, you could put it in a bathroom or even in the crawl space. You know, you could also have your attic access here. So in this closet, you have your floor, your crawl space access underneath, and you have your attic access right above. So it's just a planning problem you need to think about. But the key things to pay attention to is the minimum headroom size and the minimum opening or ceiling opening size for your attic access. Let me get water, please.
Okay, I do it.
Yeah, thanks. So, one thing I also want to mention about ceiling
Yes.
joist. I don't know if I should use the same sketch or okay. Let me do another one. Let me share this one with you. Okay. Or maybe I should wait till we are going over sections because we'll still go over sections.
Okay.
So I will still remind me to talk about the ceiling joist. But that's the concept
Okay.
of attic access. In most projects, in fact, every project should have an existing attic
Okay.
access. If you are doing an existing build and there's an existing attic access, you need to ask
Yes.
the client or the architect or whoever is giving the project where is the
Yes.
existing attic access in the
Yes.
house. So that must
Yes.
that has to be shown on your floor plan.
Yes.
Now, I want to share a scenario with you because sometimes you could have an existing attic access and you need to provide another new attic access. So I will describe that scenario now. Say you had this building
Okay.
footprint. Let's say your existing house was shaped like this. Let's say it was like this. And now you want to do, let's say the roof went like this. Let's say you had like gables here, and then you had this, your slope direction. Let's say you had your slopes to be like this. And then you had a valley here. So you had a slope here. Now you want to do an addition to the house. Let's say you were now adding a new space here. Let's say you added a living area here. This is the new addition to the house, right? Are you there?
Yes.
Now, if you introduce.
I did. I can't tell.
Let's say you now introduced a gable roof going over that addition like this.
Yeah. You join into the old one.
Yes. This one, let's say they had their existing attic access. Yeah. Let's say they had their existing attic access. Yeah. Now, one question I want to ask you.
Yeah.
Can that existing attic access suffice for the new addition? One principle you should know is every attic space in the house must be accessible. That's one principle you should know.
Yeah.
Now, my question is, if you had the existing attic access, can that attic access cater to this new addition?
Well, I think since for joining this, they'll be cutting through the roof, right? The existing roof.
Sometimes what they do is they cut like circular openings for the purpose of just ventilation, but they don't want to compromise they don't want to compromise the structural rigidity. So the opening will not be the opening would not be enough to allow for human access. So in such a situation, you must now provide a new attic access, bearing in mind the minimum opening requirement, 30 by 22 inches minimum, and minimum headroom of 30 inches. So that's a good one. Let me share that image with you. So that reminds you, if you have an addition, you must also think about new attic access for that addition. Yes. So all the other information on the plan are pretty much self-explanatory. Remember, we are looking at the what is it called, the SLC method. Now you can see in the garage they also have two existing attic accesses to be retained. Okay. This is the existing roof plan. You can see the sunroom is being removed. So the roof over the sunroof, the roof that goes, it's a shed roof they have over the sunroom. It is being demolished. So on our roof plans, we like to show slopes, the wall outline, for the building below. So to achieve that, you can choose to
Okay.
maybe change the wireframe, then use a single overhead line type to trace over the exterior walls alone. You don't need to trace the interior walls too. So that tells you that, and when you do that, you can now switch back to hidden line, and then that gives you the what's it called, the existing building outline.
Yeah,
If you
yeah.
if you have space, you can also point at the materials. You can tell us it is existing asphalt shingles, existing chimney, existing building outline. You know, you also tag the elements in question for this project. Now the Chi method, I will just, this project you see here is the Chi method. You remember the one I've been describing
Yeah.
all along is the SLC method.
The SLC. Yeah.
Yeah, the Chi method now,
Yeah.
we like to show the roof plan on the site plan. So you don't need a separate roof plan. And then you now annotate everything, you know, directly on that site plan. This is the Chi method. You know, you tell us the roofing
Yeah.
material, the the what's it called, the skylight specification. You also provide that. The Chi method also prefers to have the allowable setback lines in blue. You know, so this is the Chi method. So back to the SLC method. We are now looking at the proposed floor plan. And the proposed floor plan, in addition to all the information we added on the existing, you can see that the new now, we are going to be showing new space names. Space names will now be carrying N, where
Yeah.
you have new
Yeah.
conversions or new spaces. But those existing ones that you do not tamper with, they will still be carrying E.
Yes.
Well, here now we have new office, N in brackets, new office 1, new office
Yeah.
2. The ceiling is going to be new. That's why you see N in bracket next
And
to
yes, under it.
ceiling height.
Yeah.
Now we've removed one of the existing attic access. You know, we previously had, if you check the existing site plan, we previously had 2 attic access.
There was one at yes.
Yes, but now
Yes.
we've removed one of them. So windows to be added, you use your normal shorthand to depict them. Now you have sheet notes for the new, but this particular project you are looking at, the sheet notes are not that many. I'm going to be walking you through another AutoCAD project where we had more sheet notes. Let's see this. The sheet notes are very critical in any project you are doing, because
Okay.
that's where you specify code compliance. That's where you show that the project is actually compliant. You know, there are some things you need to
Yes.
show there. Okay, this project you are looking at involves
Yes.
a conversion into an attached ADU and a JADU, a JADU. This is the JADU unit. This is the
Okay.
ADU unit, the ADU rather. And then this was the existing
Yeah.
house. So they altered this space and then they blocked off this opening in order to create the ADU with its own separate access from the exterior. And then you have the JADU, which is connected with the rest of the house through this door here. So this is the JADU. And I told you what differentiates the ADU from the JADU is the fact that you can walk from the existing main house into the
To
JADU.
the space, yeah, the joint system. Understand?
Yes. So one thing you should note here, but our purpose of looking at this project is not to walk you through the scope of work, but to explain sheet
Yeah.
notes, because there are more sheet notes here. So the sheet notes, you can see all these stacks with which we are pointing at different appliances, different fixtures, and different aspects of the work. So we are going to be going over some of them. The way I like to do sheet notes is I start with the note and I figure out which notes are relevant to the scope of work I'm doing. For instance, if you are doing a project and there is no, you are not doing anything relative to the kitchen, you are not demolishing cabinetry or adding new island or whatnot, then you are not supposed to have any sheet notes referring to any kitchen appliance because that's not within the scope of the work. So when you're going over the notes, you need to be mindful of which notes are relevant to the project you are doing based on the scope of work. So your new proposed plan, the first note. Hello, if you're on the call. Hello, are you on the call, if
I'm listening. I'm not. Can you hear me loud and clear?
Okay.
Can you hear me?
Yes, I can hear you now.
I'm planning.
So the new proposed sheet notes.
Yeah.
We are looking at that now.
Yeah.
Note one says provide electrical cooker, provide power with new exhaust hoods, provide a ventilation exhaust hood
Yeah.
with a rate of 300 CFM. Also, cooking appliances shall have a vertical clearance above the cooktop for not less than 30 inches to the combustible material or metal cabinet, except where 24 inches is allowed per code or manufacturer spec. So this is specification relative to the electrical cooker. One quick way, for now you may not be able to fully grasp the significance of all these notes, but one quick way to go about it is to identify which appliances are you referring to. So this sheet note one now refers to the electric cooker. So what you do, you go to your plan. If you have an electric cooker, you point note one at it. Alright, these are electrical cooker. But if you have a gas cooker and you are pointing electrical cooker to it, then you are wrong. So you should know which cooktop you are implementing in the project, and you should know which notes should be applied to it. So note 2 says range hoods shall be permitted to be cut and plugged with a flexible cord. This should be cord, not cords. With a flexible cord identified as suitable for use on the range hoods in the installation instructions of the appliance manufacturer where all the conditions are met. The flexible cord is terminated with a grounding type attachment block. The length of the cord is 18 inches to 4 feet. Receptacles are located to protect against physical damage to the flexible cord. The receptacle is accessible. The receptacle is supplied by an individual branch circuit. When I'm explaining electrical panel, I will talk about what we mean by branch circuit. But basically what you should know is that this range hood, this note 2 refers to the range hood, which is usually installed over the cooker. So if you see your gas cooktop or your electrical cooktop, and you see this dashed outline over it, that's going to be your range hood. So we are pointing note 2 at this. In the case where you just want to use one arrow, you can just attach the next note. So you see they are joined. You know that all 3 notes refers to that appliance that is being pointed at. So note 3 says electric stoves and ovens shall be supplied with 40 or 50 amp branch circuit. Note 3. Remember, we are dealing with electric cooker, and that's why we are talking about the branch circuit that supplies that electrical cooker. Number 4, provide new sink with Carl Green compliant faucet with new garage disposal. So note 4, garbage disposal rather refers to your kitchen sink. You know the garbage disposal is usually connected to
Under
the sink.
the sink. Yes.
Yeah,
Yes.
so
Yes. Yes.
that's note 4. You point at the sink.
Yes.
Note 5. New refrigerator or ice maker. So you just go to your fridge and point note 5 at it. Note 6. Solid countertop with upper and lower cabinets. So your countertop in the kitchen is note 6. It has upper and lower cabinets. Note 7. Countertop where the overhang does not extend more than 6 inches beyond its base. Or note 7, still your countertop. So you're telling us the overhang should not go beyond 6 inches beyond its base. What that means is if you add a section to your kitchen countertop,
Mm-hmm.
it looks something like this in section. The note is telling us that this distance should not be more than how many inches? 6.
Okay.
That's essentially what the note is saying.
Okay.
So it's a specification basically for your countertop. So you're going to
Yeah,
point, you're
the
going to
countertop.
point 6 to your countertop. You see it? Now note 7 says, or note, we just went over note 7. Note 8 says, for window modifications, replacement and new windows shall have a U factor equal to 0.3. That's also a specification for windows. You don't need to point anything for this one because it's generic. It says that any window
Yeah.
modification you are doing must have a U factor of 0.3. Note 9 says provide WCs to be a maximum of 1.28 gallons per flush. That's also a specification for your WC. That's note 9. So you go to your WC and point at it.
Okay.
It's note 9. Note 10 refers to your shower. Shower width, whenever it's W and slash, is shorthand for width. So shower width,
Yeah.
full height style walls,
Yeah.
and tempered glass enclosure. Use B2, I think it's B2 thin, and then 4000 waterproofing membrane over half an inch wonderboard, walls and ceilings and floors. This is the specification for how you want to construct the shower. So that's note 10. You go to your shower and point note 10 at it. Also note 11 and 12 refer to the shower. New solid surface, non-slip resistant shower pan and walls. That also refers to the shower. Note 11. Note 12. Provide shower finished to be 72 inches above drain. Provide pressure or thermostatic mixing valve at shower and jacuzzi, which limits water temperature to 120 degrees Fahrenheit. Shower head shall not exceed 1.8 gallon per minute at 60 psi. So note 11 and note 12 also refer
It's
to
on shower.
the shower. So you're going to point those 3 notes at the shower. Note 13. New sink and faucets shall be a maximum of 1.2 cmp at 60 psi. Metering faucet shall not exceed 0.2 gallons per metering cycle. So note 13 is your bathroom sink. Now one way to know to differentiate your kitchen sink from your bathroom sink is that the kitchen sink tends to have reference to garbage disposal. That's one way you can tell them apart. So the note that is talking about garbage disposal, you know that this one is referring to the kitchen sink,
Kitchen sink.
and then the other one
Kitchen
is
sink, yeah.
for the bathroom.
Bathroom sink.
Yeah, note 14 is a new wall-mounted split unit. So if you have an indoor unit, this is note 14. For the sake of others, let's see the split unit air conditioner. So this is what it looks like. This is the indoor unit, and then this is the outdoor unit. This one stays outside, and this one stays
Yeah.
inside the house. So this note 14 is referring to the indoor unit for your split unit. So new wall mounted mini split unit. They are specifying where they want the indoor unit to be installed. And this TYP
Okay.
dot you see under is typical. So you are saying any other place on the plan where we see the symbol, then we should know we are also referring to the indoor unit. So that's the TYP. You see, it means typical.
Anyway, I see what that.
This same symbol on the floor plan, you should
Yeah.
know you are referring to
Yeah.
the indoor unit. So you don't have to now come here and tag 14 again, because on this one instance, we've
Okay.
specified this to be typical TYP.
Yeah.
That's
Yeah.
note 14. Note 15 says new tankless water heater. So you go to where you have your tankless water heater and point note 15 at it. Now, about water heaters, there are two types. You have your heat pump water heater. This is what they look like.
Okay.
This is the abbreviation HPWH. Heat pump water heater.
What time is that?
Here is this one that has a cylindrical form. You know, you have your like a
Yeah,
tank
yeah.
in it.
Yeah.
So this is a common one. When you see them draw a cycle on the plan and then they type WH or HPWH,
I mean,
then they are referring to
yeah.
a heat pump water heater.
Chill. Chill,
Okay.
chill. Sorry to interrupt you. The It's
Okay.
the same as the tank. What time is that now?
Tanked, yes. It's also that's yes,
Yeah.
that's another term.
Alright.
Now the
Alright. Let me go
the
first.
tankless water heater has this minimal, this rectangular or should I say cuboidal form. It's very portable. It can be
Yeah.
installed anywhere. You know, I don't know why it keeps referring me to AliExpress. I'm not buying. I just want to show samples. So this you can see this is what the tankless water heater looks like. It's installed on the wall.
Yeah.
It's supplied with a gas supply. It's usually powered by no. It could be electrical. It could be gas too. But what you
Yeah.
should know that it has the benefits of saving space, right? If you have most, this is the more modernized, um, should I say, water heaters that people like to install nowadays. But in Cali, they like you to also
Yeah.
provide space for the heat pump water heater. Most people just install tankless when they don't have space for a heat pump water heater.
Yeah.
So the
Yeah.
code says because now they think most people go for tankless because they don't want to bother themselves with providing space for the heat pump water heater because
Yeah.
there are very strict requirements for the space you provide for your heat pump water heater. So the code says whenever you are providing a new tankless water heater, you should also provide or show us space where you have your heat pump water heater. Now,
You
it's
provide
not
what? I didn't get that.
space for your heat pump water heater.
Okay.
You are not
Okay,
providing
yeah.
the water heater itself, but you must show the space
Yeah.
where it would occupy in a future scenario where you want to install the heat pump water heater. So the way to
Yeah.
show that is to identify a space. If you are lucky on your floor plan and you've had a separate enclosure for your water heater, then that's all. You don't need to
Yeah.
start scrambling to provide the space. You can see on the other project on Revit, we already showed or created a compartment for the heat pump water heater.
You need some water heater, yeah.
Now, if you didn't have that space, you need to now create maybe an outside enclosure there's a minimum dimension that it must occupy, and then it needs to be at a particular distance. It should not encroach into your setback. That's another thing to note. If you're putting it beside your wall, it should not
Okay.
encroach into your setback.
Into the setback. Yes.
There's a minimum dimension, and it should have a dedicated branch circuit. You see, we provided the wiring
Mm.
for it to the outlet, and the outlet has to be waterproof, it has to be GFI, and it has to be 20 volts. So that must be shown whenever you are providing a tankless water heater. So yeah. What next? What next? Yes, for the tankless water heater, right? This one. If you choose to put it in your garage, let's say we decide to put it.
Hello?
Hello, are you with me, Fair?
I am.
Yeah, I can hear you. Can you hear me?
Hello?
Hello, if I can hear you, can you hear me? Oh, why is the network misbehaving? So, I was trying to explain that the tankless water heater, if you install it in the garage, then you need some kind of protective feature for it.
Sorry.
So what I
Yeah.
mean is, let's say you wanted to install it in this garage here. Let's say this is where we wanted to put the tankless water heater. You need to protect it from impact because you know vehicles park here, right?
Yes. Yes.
So you need to be able to protect it. So someone that is either trying to back or reverse will not go and hit the tankless water heater. So one common approach is to have
Yes.
a steel bollard here at the distance from the front. So that ensures that if someone is, you know, going too far towards the
Trying
tankless
to-
water heater, this could
Yes.
prevent the person from hitting
Okay.
the tankless water heater. Not
Yes.
just because they are protecting the
Yes.
heater itself, but because it's a gas appliance, and you know gas poses
Yes.
high risk of fire safety. So you don't want any.
Yes.
It's not because
Yes.
the tankless heater is more expensive than the car. It's because you do not want any fire incidents due to
And
impact.
fans.
Yes. So that steel
Yes.
bollard must be designed if you ever want to install it in the garage. Concrete filled steel bollard actually, because it's usually hollow steel and they fill it with
Okay.
concrete.
Oh no. Yes.
Steel bollards. So I guess that's it for water heaters. So now on to the next thing. So for the sheet note, right, there's obviously going to be more. I would provide maybe
Yeah.
what I'm going to do is I'm going to create a Google Doc file where I would provide all the possible
Okay.
um, existing and demolition notes and all the
And
possible
yes. No.
new proposed notes. So anytime you are working on a project, you can go over the notes and look for the ones that apply
Just be checking. Yes.
to the scope of work. So that would be a very handy material to have. Okay, but just note that these lists are not intended to be close-ended. If you feel like there's
Yeah.
an aspect of the work that needs to be specified, but you can't find in those documents, then by all means,
Yeah.
feel free to do your research, add it, and possibly draw my attention to it so
yeah,
we can grow the list.
yeah,
But basically, that's the concept. Now, all these things have significance, right? What I've just shown you is a shorthand for how you can quickly comb through it and then identify which appliance or plumbing fixture you need to point at. But there's a basis
yeah,
for all of these things. For instance, the water closet that you want to keep at 1.2 gallons per flush, you are this is the maximum value actually. The benefit of this is it's going to provide
yeah,
savings. You know, you are not consuming excess water, and by doing that,
yeah.
it means it's just contributing to the
Well,
sustainable features of the house or the home. You know, usually in Nigeria
yeah, yeah,
we don't provide this enforcement that okay, anybody that is installing a WC in their house should make sure the maximum flow rate
yeah,
is
no,
1.28
yeah,
gallons per flush, and by not
yes,
providing this, you know, enforcement, people just waste water in their houses
enforcement, yeah.
to flush.
Without, yeah, yeah, yeah,
So it's part of the Cal Green features. Someone may want to say provide Cal Green compliant WC. That's also a valid way of expressing this note. So you are saying, okay, the contractor should go and look at Cal Green and find out what kinds of WCs are allowed,
please,
and that's what they should install in the
yeah,
property. But if you are, should I say, if you are a kind architect, you would save the contractor that stress by
yeah,
including the
yeah, that's
feature
fine, yeah,
itself. So all these things have reasons for why they are being specified, and most of them relate with Cal Green, you know, and some of them. So now they are not all about sustainability. Some of them are for the safety of the occupant. You know, there's this thing they
mm,
call aging in place. I'm supposed to go
yeah,
over a project that we did that involved aging in place. You know, we had to start designing blockings, we had to specify
yeah,
all those details. But basically, what you should bear in mind is some of these notes relate to the safety and ease of use for the occupant.
of the occupant, yeah,
Some of
yeah,
them relate to the sustainability of the house. Some of them relate to the energy
yeah,
efficiency of the house. So you need
yeah.
to bear these in mind. And some of them relate to
This
just
is
general
the,
convenience. You know, like here they are saying provide new 1 hour fire rated type X. This is for fire protection, right? If you can recall the type X I explained
yeah,
earlier. Now, fire
yes,
protection
yes,
is basically relating to the safety of the user, because if there's a fire incident, you want to make sure the walls, the roofs can stand for at least 1 hour during the fire incident before they
before,
completely
yeah,
break down or collapse. So that 1 hour, it's assumed that
yeah,
anybody trapped within the building can be evacuated before the eventual
yeah,
collapse.
yeah,
So that's the concept. All penetrations in 1 hour fire rated walls shall be listed and or rated to comply with CRC 302.41, 302. So if you have 1 hour fire rated walls, they need to any kind of attachment or penetration you are designing into the wall must
yeah, that,
must still, you know, retain the fire protective features of the wall, because if you just punch out through and put any kind of pipe, that may jeopardize the whole fire protection of the wall. So you need to install what they call
yeah, yeah,
fire stoppers. You know, these are the things you build around the pipe. This is supposed to be a pipe. So you see all these things going around it, they are fire stoppers. So
yeah,
whenever you have a penetration through a 1 hour fire
yeah,
rated wall, you need to ensure that any penetration through the wall is compliant, meaning such a penetration will not reduce the fire protective features of the wall. Now you also have
on the wall.
membrane penetration. You have pipe penetration and membrane penetration. I didn't provide the detail for membrane penetration, but I'll show you. I have it here. Um,
Okay.
so membrane, this is what it looks like. If you have, okay, this is it. If you have, maybe you want to install an outlet or your electrical panel in the wall, that panel or outlet needs to have
Yes.
either the panel itself has a fire stop built into it, or you enclose that box in a fire stopper. So some manufacturers will design the outlet to be fire resistive itself. It's built into the outlet. So in such a case, you don't need to now add any fire stop. But where that is not provided, you now need to introduce the fire stop into the it goes around the membrane. The difference between a pipe penetration and
Yeah.
a membrane is that a membrane will not completely pierce through the wall. It's more like
Through
an
the wall.
embedding.
Okay. For the
It's more
pipe.
like an embedding within the wall. But
Yeah.
a pipe penetration, as the name implies, it's a pipe or a sleeve going through the wall itself. So the wall is section, the pipe goes all around it. So the concept is you must have a fire stop. You can see this four. This is the fire stop that is designed around the membrane, the pipe penetration basically. So you can also have, you can see the detail says 4 is the fire stop sealant. Now you also have an elastomeric sealant. It's also a fire stop sealant. But just think of it, the concept is just to have a fire stop or a sealant going around the device.
Yeah.
So that way you are protecting the rest of the wall from the weakness of the pipe or the membrane. So whenever you have
Yeah.
1 hour or 2 hours or any number of hours fire rated wall, you have to show details for both the pipe penetration and the membrane embedding. So back to San Clemente, we've looked at the proposed plan note. I said I'll be providing a comprehensive list. So for every project, you know where
Yeah.
to draw from and
You
what
don't
to
test it.
exclude.
Yeah.
Yes. And then the rest are graphical, representation. So you are just going to be looking at, just study the plans and see all the things I'm doing. Everything matters. Everything.
Yeah.
So
Yeah.
just look at the plans and ask questions if there's anything you see me doing but I have not addressed. But remember what I said
Yeah.
about the SLC method. We like to have view titles
Yeah.
towards the bottom left of the viewport and not arrow towards the bottom right of the viewport.
Yeah.
Now electrical plans. We need to look at a more comprehensive electrical plan because there's quite a whole lot going on there that I need to explain. Will this one do? Okay, I think we could make do with this. Okay. So for electrical plants, I will start with how the wiring works from your service cable as the one that brings in lights from either your pole or your underground pole, the electrical main or your service main.
Yes.
That's the main wiring coming from the city. It could be underground and it could be overhead. I've done plans where we had to show the pole on the side plan. So in the case where you have an overhead electrical service cable, you need to show on your side plan the location of the pole, right? Let me show you
Yes.
a drawing.
Yes.
I think I've done a project where we had to
Is
show
that the
it.
PL on the site plan?
Which one?
Huh?
No, PL on site
There's
plan is
one PL.
property line.
Okay, okay.
That's just a symbol for property line.
Okay.
I'm trying to locate a project where we had to show the electrical panel, the service main rather. Let's see if it's this. Okay, I think it's this, but this. Okay, I think this was a complete plan we submitted. No, I'm not sure the electrical pole here. Let's see. Okay, great. So this is the Kai method though. This is not SLC method.
Yeah.
But what I want to
Okay.
direct your attention at is we had to locate the electric pole. In fact, it was the city that said we should go and provide the electrical pole location. That's why you see a revision cloud over it. But we had to show the location of the electric pole and the overhead electric service main that now goes to your electric meter and panel. Right? So you are showing the overhead wire, you are showing the pole, and then you are showing the service panel. Sometimes on the site plan, if you have a fire hydrant nearby, you need to indicate it.
Yeah.
You know, we've shown water main, we've shown sewer lateral. Remember the sewer lateral? So it goes all the way
Yes.
to
No.
the city sewer main. All our 2% slope away from building, all of that was shown. But what I want to show you here is the electrical pole. And then we had, in the initial submittal, I showed the pole as an underground service main, but apparently it's overhead. You understand? But this panel you can see here, this meter you can see here, shows that the service main
Yeah.
is underground. So it's coming from below grade and then going towards the meter. Okay, yes, this project had aging in place requirements. So I'm going to still go back to aging in place, but that's after I'm done with the electrical plan. So let me just do a sketch so you understand what's really happening.
I did.
So you have your electrical main. Now it goes to the electrical meter and then it also goes to the service panel. So this is your electrical meter. Sorry, let me sit down properly. Oh God. So this is the electrical meter, and this is your electrical panel. This is your service wire. Now, from the electrical panel, you could have sub panels, and you could have branch circuits. Remember, I said I was going to explain branch circuits earlier.
Yeah.
So you are now the panel is just like your distribution board, which consists of circuit breakers and branch circuits. So you have several of them. You have 15 amperes, you have 20. Let me use another color. You have 15 amperes, 20 amperes, 30 amperes, depending on the load you want to design or you want to support, and so on. Now, your sub panel, use your electrical sub panel. It's usually like 100 amperes, but it could be less, or
Yeah.
it's usually like 100 amps. But your electrical meter is usually like, no, not your electrical meter, your electrical panel, the main panel is usually like 200 amps. This is what comes from your pole, right? It goes to the electrical meter where
Yeah.
it goes to the
Electric
electrical
meter,
meter
yes.
where you rate the consumption, your load consumption, and then from there it goes to
Yeah.
the electrical panel. Sometimes you could have them to be combined. Sometimes you could have the same device to have the panel and the electrical meter to be integrated into a single device. And some other times they could be separate. The electrical sub panel is a situation where you have the main house and maybe you have an attached ADU, but you want the attached ADU to derive its supply from the main electrical panel. So that's the situation where you could have the
Yeah.
electrical sub panel, but it's not required in every project. If you don't have that kind of situation, then you don't need an electrical sub panel. So let's say you had now, yeah, this goes to all the appliances in the house, your fridge, your gas cooker, no, your TV, your you know your electric cooker, and so on, and even your heat pump, water heater.
Okay.
So all these are branch circuits. All these wires you see here coming from the electrical panel. These are your branch circuits. I'll just abbreviate as BC. These are your branch circuits. Now,
Yeah.
before you design or you size the electrical panel,
And you do what?
before you size the electrical panel, before you determine whether it's 200 amps or 400 amps
Yeah.
or 100 amps, you need to know the load requirements or the load demand. Um, Load, there's a calculation to this, but you don't usually. My client has another consultant that does that for them,
Now.
so they only provide me with the information that, okay, based on their calculation, that we are meant to use a 200 amps electrical panel. So this is called the load
Yeah.
demand. So you just have to know it that sizing the electrical panel is
Yeah.
dependent on the load demand. So when they determine the load demand of the house, then they can now determine the appropriate panel size to use. So I'm going to share you this image. This is a basic description of the electrical system. Okay, sent. Now, what does the electrical panel look like? So it looks like
I've seen it.
this. You can see all these circuit breakers inside. So they are all rated 15 amps, 10 amps, 30 amps, and so on. Now, if you have a device that demands higher, like your refrigerator or your AC or your electric cooker, you cannot go and attach or connect that circuit to a 10 amps or 15 amps circuit breaker. It would fail, it would break, it would burn because the load demand of that appliance exceeds the capacity of that circuit breaker. So there's this thing they call panel schedule. So this electrical.
Hello?
Hello, are you with me? Hello, Ife. Hello? Hello, are you there? So what I was saying is the electrical panel shows different circuit breakers for different branch circuits. So this circuit breaker there will be a branch circuit. To this one there will be another branch circuit, and so on. Right? Now,
Yeah.
now what you should note is each circuit breaker has a rating. So it could be 15 amps, 10 amps, 30 amps, and so on. Now, if you connect an appliance to a branch circuit that exceeds the capacity of that branch circuit, it's going to fail. The light is going to trip off. The circuit
Yeah.
breaker could burn. Now, you need to ensure the load demand and the panel are compatible. So that's where an electrical panel comes in. So you don't need to do this. Like I said, my client has a consultant that does the electrical design for her. But yours is to understand the principle and then to be able to design the floor plan. So now I've explained branch circuits. Basically, branch circuits are the circuits you connect from each circuit breaker on your panel. So if you look at other images, you are going to see different connections to different circuit breakers. So now back to the electrical plan. You have your recessed lighting, you have your outlets, and outlets come in various sizes, and then you have your switches, and then you have your exhaust ducts. Those are the main, and then wall lamps too, chandeliers. What else? You also have pendant lights. Those are the kinds of, you have smoke detectors, you have carbon monoxide detectors. Those are the main appliances we designed for, and on the electrical legend, those would always be shown for you. Now,
Yeah. Yes.
for the electrical outlets, another name for them is electrical receptacles, right? They are your normal plug-in, your wall sockets basically. They are your normal wall sockets. These are electrical outlets or receptacles. They could be single, they could be duplex. You know, this is a duplex one because it has double. This is also a
Okay.
duplex. So all those have
Yeah.
symbols. You know. Now, on the legend, when you see them indicating 12-inch above floor level, they are telling us above finished floor rather. They are telling us that this outlet will be installed 12 inches above finished floor, or 32,
Okay.
32 to 36 inches above finished floor at counter. So this tells you that wherever you are installing an outlet, you need, if that outlet is
Yeah.
not within a counter or above a counter, it's going to be 12 inches above the finished floor. That's the meaning of this AFF, above finished floor. But if it's installed where you have the counter, then it has to be 32 to 36 inches above finished floor. That's definitely going to be above your counter. Now, hello, can you hear me, Fair?
No? I am.
Yeah, I can hear you now. So you had my
Yes, yes.
explanation for
I'm here. Yes.
you had my explanation
Yes,
for the
about the
outlet.
counter. Yes.
Okay,
Yes.
great.
Yes, I did. I did. Yes.
Now, your another type of outlet you could have is the GFI or GFCI.
Yeah.
Is the full abbreviation is GFCI, but on your drawing you are going to abbreviate it GFI. So that GFI outlet
Okay.
is what you
Yeah.
called ground circuit interrupter. So basically, you are grounding that
Okay.
circuit. You know, not every circuit will be grounded, right? Now, the ones that are grounded
Yeah.
are abbreviated GFI on your drawing, or GFCI if you want to go by the full
Okay.
abbreviation. And GFCI means ground fault circuit interrupter, and it's used in areas that are prone to wetness, moisture, like your kitchen, your bathroom, or the outdoors.
Bathroom. Yeah.
So those are the areas where if you are installing an outlet, you must use the GFI variant. You cannot just install a regular outlet in a wet area.
Yeah.
That's the concept. Now
Okay.
you could have 240-volt outlet. Those ones will be used in your kitchen where you have your electric cooker
Mm-hmm.
or your heat pump water heaters. Hello, are you there?
I get with you. I can hear you. I'm listening.
This
I
is
hear you.
this is I'm
I can hear
mentioning
you.
now, yeah.
Yeah.
This is I'm mentioning now. I'm emphasizing them because I looked at the electrical plans you sent, and I noticed some of these things were
Yes.
not they were not put into practice. That's why
You were missing.
I'm really spending my
Yes.
time on them.
Yeah, I'm getting it. Yes.
Okay.
Yes.
So the 240-volt GFI outlet is used where you have your electric cookers and your heat pump water heaters and your ACs. Anywhere you have some of these high powered devices, that's where you install the 240-volt GFI outlet. Now you have the outlet that has WP. It means it's waterproof. So if you are installing an outlet outside,
Yeah.
it both has to be waterproof and GFI protected, because if it's outside, rain can fall, sun can shine on it. So it has to be grounded
Yeah.
and it has to be waterproof. So both both abbreviations have to be used. Now, your LED light fixture is just your wall hung light fixture, but on the interior, this one with the circle and cross is your interior LED wall light. Now your exterior LED wall light is this rectangle with the cross in the center. So of course we all know what
Okay.
a wall lamp looks like. So this is what the exterior wall lamp looks like. There are different designs, obviously. Now, you could have the interior one too, which you could use in your bathroom, or let's look at the one you use in the bathroom. So you have all these variants, you know. So what other appliances I've not mentioned? Your switch. Your switch is usually at
Yeah.
48 inches above floor level. This should be AFF. Now you
That's
have,
it, sorry.
yeah, thank you. You have the vacancy sensor switch, which is a type of switch that senses the space for any occupant. If the space is vacant, then it goes off. It's kind of like motion detector, but not motion detector. Motion detector
Okay.
appliances detect movement in space, but vacancy sensor detects presence in space. So if someone is in that room, the vacancy sensor will detect and then automatically come on. But if no one is in the room, the vacancy sensor goes off because it has detected that there is no occupant. And hello, can you hear me?
Look, I can't hear you.
Hello, can you hear me now? Hello?
Hello?
Hello, can you hear me?
Hello?
Hello, if I can hear you, can you hear me?
Hello?
Good. Hello, I can hear you. So, what I was explaining, the vacancy sensor switch detects presence in space. If someone is in a room, it detects it, and then it goes off if the person leaves the room, and then it comes on if the person enters the room. Now, it's commonly used in bathrooms, right? If someone enters a bathroom and you don't want to stress them by on the light switch.
Hello?
Hello, can you hear me? Hello? Ah, voila. I said, now there's one other term which is quite similar to the vacancy sensor, and that's the occupancy sensor. So the difference between the vacancy sensor and the occupancy sensor is the vacancy sensor needs to be turned on manually, but it turns off itself automatically once the occupant leaves the space. But yes, but it needs to be turned on manually. While occupancy sensor, on the other hand, detects presence in space, and then it comes on, goes off, and adjusts automatically depending on the number of people in the space. So if there's more people in the space, that one will adjust lighting, brightness, and intensity, and all that. So it's just good to note the difference. Now there's the bathroom exhaust fan, usually having LED light and moisture control integrated into it. So the job of the bathroom exhaust fan is to take out foul smell and foul air from the space to the exterior. So it keeps your bathroom from having a foul odor. So that's usually in the bathroom. Okay. Yeah, I'm with you.
This project are currently running. In the case where we have the room that is stuck in this space, that is not sharing any external flow. Do you get now?
Yes. How did they? Yeah, I'm with you. So,
Yes. You can reposition it because in that case there's no window now. Like this, there's the
Okay.
first one. What do you think now?
it can be vented to the
So
roof. It can be vented to the roof.
This 443 it will can be vented to the roof.
Yes,
Okay.
it can be
Okay.
vented to the roof.
I don't know if there is anything peculiar to the positioning. I feel maybe there's something peculiar. That's what I want to know. You have any listen. Do you get my question?
Yeah, I understand.
Yeah.
Trying to look for a drawing that shows it's being vented through the roof. So you can see here, if you have your exhaust duct
Yeah.
embedded in the ceiling, the duct itself goes all the way to the roof and then it opens on the roof. So this is the approach if you don't want to vent it to the exterior. And usually you want to vent it to the roof
Yeah.
in all cases. It's usually your dryer vent that you can vent through the wall.
Yes.
But in most cases for your
Okay.
exhaust vent, you want to vent that one through the roof. And the reason should be obvious.
In the room.
The bathroom vent, you don't want it, you know, emitting foul air into someone's bedroom.
Into the same space. If another.
Yeah, maybe you are emitting it to the exterior and just beside the bathroom you have a window to another bedroom. It won't be nice. So most people's bathroom vents, they tend to pass it through the roof. And that's for your exhaust vent. Now you have the plumbing vent too. That one is directly connected to the
Yes.
sewer pipe. You know what? That's the vent
Yes.
stack. And that one too, you tend to vent it through the roof. From seeing this image, I can imagine this one to be
Okay.
the vent stack from the plumbing, and then these two to be
Okay.
the venting from the kitchen, the bathroom exhaust fan. So,
Yeah.
so those are the main appliances we tend to design into our project. So now with this understanding, okay, I've not mentioned smoke and carbon monoxide detectors. Sometimes
Yeah.
you have them combined into a single appliance. Some other times you separate them. The SLC method tends to have them combined,
Yeah.
but the Chi method tends to have them separate.
Okay.
So let me look for an electrical plan on that was done by the Chi method. So you can see here we have two separate devices for our smoke and carbon monoxide detectors. This is a symbol for just a
Yeah.
smoke detector, and this is the one for carbon monoxide detector.
The carbon monoxide
So
detector.
the the SLC method likes to combine them, but the Chi method likes to separate them.
Separate them. I know.
Now, for the electrical plan itself, uh, what we do is we lay out the recessed lighting first on a grid, right? The principle is
Yeah.
for your regular spaces, your living room, your bedroom, you want to have them in two rows basically, but any number of columns, or two columns and any number
Yeah.
of rows.
On road.
Yes, you don't want them to be more than like maybe 10 feet apart, but usually you can visually determine how many recessed lighting
Yeah.
you need for your living spaces.
Mm.
Now your bedroom, usually we have just four of them, and you want to keep them to usually like 2 feet away from the bedroom, or in the bedroom or not the living room. If you go to the living room and you are making sure this
Yeah.
2 feet from the wall, that may be too clustered. So for the bedrooms,
Yeah.
you want to keep the recessed lighting to 2 feet from the walls.
The-
Now,
Okay.
you want to also centralize them. Now, if you have a ceiling fan, you
Yeah.
put it in the middle, but we tend not to use ceiling fans. We just like to have recessed
Yeah,
lighting
fine.
and separate HVAC system. Now, your smoke detectors, you usually want to put them in the vicinity of the door to your bedrooms. So usually
Yes.
this
Yes,
one
I know that. Yeah.
this one you want to put it ideally somewhere around there. That's the principle. So that's for smoke detectors. For the kitchen recessed
Yeah.
lighting, you want to keep them 3 feet from the kitchen wall. You understand? You want to
Yeah.
you want to keep them 3 feet from the wall of the
From the
kitchen.
kitchen wall.
Yes. So usually what we do in the Kai method is we draw this
Okay.
faint line. We draw this faint line, or you could just use a regular center line and apply the half tone to it. But usually that line is meant to be a guide for where you position the recessed lighting. So usually for the kitchen counters,
Yeah.
we want to keep that line to 3 feet
Yeah.
from the kitchen wall. Now you could have pendant lighting over your kitchen island. It could be two, it could be three, depending on your design. You could have a
Yeah.
chandelier
Okay.
in the living space, directly in the living area. Um, Now all of these appliances have switches, obviously, and
Yes,
the
of
way you
course.
design the switches depends on a. You should think of a user trying to navigate that space and how best would it be positioned such that the user wouldn't have to walk needlessly across the room to go and access the switch. What I mean is, let's say you had this layout for your recessed lighting. Ideally, you want a switch next to the entrance, the main entrance, right? That controls the lighting.
Yeah.
But also, you
Yeah.
want to have another switch accessible to this hallway or this bedroom, such that if an occupant is coming out from this bedroom, you don't want them to now come all the way to this other main entrance before they can turn on the lighting here. You want to ideally have a switch somewhere here or here, such that the occupant can immediately come out of the room and they access the switch
And sweet. Yeah.
that
Yeah.
controls the lighting for that space they find themselves. Because if the room is dark, how do you expect them to navigate to the other end in
To
order
navigate.
to access the switch? So usually what we do in such cases is to have a two-way switch controlling the lighting for that space. So this is how we represent two-way switches. You have your switch and then the number 3 next to the switch symbol. So this switch that was
Yeah.
here should have been positioned here. What we did, why we introduced this switch here is previously the door to the bedroom was here. So after we moved the door here, I forgot to move the switch
To
right
change.
beside
Yeah.
the door to update
Yeah.
the location of the switch. But ideally,
Yeah.
you want to have a two-way switch controlling the lighting
Yeah.
in the living area. So let's look at the Kai method. The same principle applies to the Kai method. You have your two-way switch in the living, and then you want to have the switch near the hallway or some other location such that someone coming out from
Yeah.
another space wouldn't have to walk all the way to the main entrance in order to turn on
Yeah.
the main switch. So I decided to locate the three-way switch here such that someone can access or control the same lighting from this hallway.
From that end.
Now for the pendant lighting and the kitchen recessed lighting, they are both
Yeah.
normal switches, they are not two-way, and we decided to position them here because the thinking is most okay, it's a reflection. So some other person may have decided to have another switch here, thereby making the kitchen switch a
Yeah.
two-way switch. So this guy is coming out from the bedroom, the bathroom. This occupant here wouldn't have to walk all the way across here. in order to turn on the
Yes.
kitchen switch. Likewise, the pendant lighting, you could decide to have its own switch here. Basically, the switches we designed here could have as well been designed here. So it's a design problem that you have to think about and decide what's the best way to position the switches. For the bedrooms, usually you want to have your switch to be directly accessible from the door. So the bathrooms should have vacancy sensor switches, right?
Okay.
Um,
Yeah. The vacancy are the one put on manually, right?
yes, you can see
Right.
what I did on this note was
Yes.
rather than using the V symbol for the bathroom,
Yeah.
what I did was to
Yes.
call out or point at the switch, and then I had a sheet note specifying that, see, the 22 tag, the one pointing at the switch symbol for the bathroom lighting, that one was
Yeah.
specified to either be an occupancy or vacancy sensor switch. Remember I said there's a slight difference between these two. The vacancy sensor
Yes.
has to be
And
turned
the
on manually,
yes.
but it goes off automatically,
Yes.
while the occupancy sensor
Yes.
comes on and goes off
It
automatically.
senses
It
automatically.
senses
Yes.
the occupancy of the space and adjusts its intensity and other parameters
Yeah.
depending on the need of that space.
Yes.
So, so one of both switch types will be installed in the bathroom and walk-in closet.
Okay.
At least one installed luminaire in each space shall be controlled by an occupancy or vacancy sensor with automatic off-on functionality in compliance with CEC. This is the electrical code that mandates the use of
Okay.
occupancy or vacancy sensor luminaires in bathrooms. So basically, just bear this in mind whenever you are designing the lighting for a bathroom.
Action. Yeah.
So another thing is you must always have your exhaust fan. Usually we place it in front of the WC. In every bathroom design, you must have your exhaust fan right in front of the WC. You must have your recessed lighting, either centralized or maybe you have two of them, but you determine the best way to distribute or lay out the lighting in the bathroom. Another thing which
Sure.
Okay.
Sure. Wait. I'm making something of it. The exhaust fan. The
yeah,
exhaust fan.
I want to.
Well, I know we discussed that it should be tagged to the cases where the toilet is still within the house.
In cases where
Well, which exhaust were we discussing the last time? The one you were showing me that I had the LED and LED this thing.
yes, it's the
Do
exhaust
you
fan.
remember?
This is it. The kind method,
Is it the same fan?
yes, it has a different
Okay.
symbol. This is just how the kind method likes to
exactly.
represent it. Okay. But the SLC method likes to represent it like this. This is how the SLC method is.
Yeah.
So it's the same component. It's still the bathroom exhaust fan.
Okay.
So I was explaining that you need
But that's when you get used to.
yes. That's because it's meant to extract foul air from the space and emit it outside.
Yeah.
Now, there's something we forgot to add to this space, and that's the wall lamp in front of the vanity top. So let's see
Yeah.
this other electrical plan if we had the wall lamp in the bathroom. Yeah, you can see in the bathroom we had the wall lamp in front of the
Yeah.
kitchen, the bathroom sink, and in some cases, you could choose to separate the switch for the wall lamp. You could choose to have like three switches, one controlling the wall lamp, one controlling the recessed lighting, and one controlling the exhaust fan. Or you choose to combine the switch, meaning you have just two switches. One switch controlling the interior lamp, the wall lamp, sorry, and the recessed lighting, and another switch controlling the exhaust fan. So, and then you need a GFI, a ground fault circuit interrupter outlet, next
Yeah.
next to the sink in the bathroom, and this is required. The GFI outlet is required because it's. Can you tell me why? Why are we using a GFI in the bathroom?
Because the wet space.
Exactly.
Talking about
It's a wet area.
putting in the wet space.
Yes, it's a wet area, so that's why we need the grounding here or the GFI protection.
Yeah.
Now for the kitchen, we also have GFIs. Can you tell me why we also have GFIs here?
Some reason because of the wetness, the water.
Same reason, correct.
Yeah.
So,
Often.
so for the kitchen, you are going to add outlets. First off, for each appliance,
Yeah.
your cooker will have a 240 volt GFI outlet, and your sink would have a GFI outlet, right? So this is your sink.
Yeah.
It has a GFI outlet,
Yeah.
and then you have another one for your refrigerator. So after applying or assigning outlets to all those appliances, you are not supposed to have outlets at each corner, and then spaced such that no appliance is more than 3 feet away from the nearest GFI. That's for the kitchen counter.
Yeah.
But for the rest of the house,
Okay.
you position the
Yeah.
outlet such that no wall surface or no point on any wall surface is more than 6 feet from the closest outlet. That's what the code says. So if you have, let me do a sketch to explain that one.
Okay.
Good. So let's say we had this interior space, right? And
Yeah.
we were trying to design GFIs or normal outlets. You know, the living room, the bedroom, they are not considered wet areas. So you don't need GFIs there. You understand? You just need the regular outlets.
Yeah.
So let's say we had an outlet here and another outlet here. And let's say we had this distance to be, let's say 5 feet. And we had this distance to be, let's say 8 feet. Is this adequate? Hey, Fair.
No.
Why is that?
No. Should not be more than 6 feet now.
Exactly. So any point on the wall or on any wall should not be
Yeah.
more than 6 feet from the exterior. So if you have this point here, let's assume this point was 7 feet
Yeah.
from this one. But you know that this
Yeah.
one is 5 feet. So it's very possible that it's adequate.
Yeah.
If this distance
Okay.
is 6 feet or below, then such a point would
Yeah.
be at least 6 feet from the nearest appliance. But let's assume we had this distance to be, let's assume we had this distance to be 7 feet. Then in such a case, this point will not be compliant. So we now have to introduce
Yeah.
another outlet, either here or here,
Yeah.
or on both corners. That way we've ensured that any point
Yeah.
within this region has an outlet close enough to it. So that's the logic for how
yeah,
you design outlets
position
into any spaces. Um, okay, so okay, let me share this so to just be a reminder. Um, so what next? I've gone over how you position outlets in the living
electrical,
rooms. I've gone over how you position
yeah,
outlets on the counters. I've gone over how you position smoke detectors, switches. Now, outdoor outlets. Remember, I said they need to be waterproof and GFI
yes,
protected. So
GFI, yes,
every home must have an outdoor outlet near the entrance. So because we have the entrance here, we are introducing a
yes,
waterproof and GFI protected outlet near the entrance. And of
yes,
course, you need wall lamps on exterior wall lamps near the entrance door. So we added one here, and that needs its own switch on the interior. So okay, I guess I've touched on the basics. If there's
yes,
anything I ever recall again, then I would mention to you. Remember, one of the first things to
go
do is
on.
to go through the electrical symbols and understand what each of them mean. For now,
Yes,
I won't be going over plumbing plan. I will record a separate video describing plumbing
for plumbing,
systems. Yes.
okay,
And elevations. We have the Chi method and SLC method for elevations. So
okay,
SLC method, she just likes to, point out each element, your window, your roof, your doors. No much specification going on here. So I like to use the Chi method for elevations. But one thing you should
elevation,
note is the graphics of SLC method. She doesn't like to do things like this. Maybe you want to point at another door here. Okay, let me use a sketch to describe that.
yeah,
Let's say you had let's say you had this elevation with a door here, a window here, and another door here, and you are annotating. Now let's say you had one referring to doors, right?
yeah,
And then let's say you had two referring to windows. One thing you want to ensure is that these things are aligned. You want to align both tags. You don't want to come and be drawing two somewhere here. If not, the whole thing starts to look so disorganized.
okay, yeah,
You want to align text,
yeah,
and if you study the SLC elevations, you see that as much as possible, she tries to align text
yeah,
together.
right, yes, yes, yes,
Another thing is you don't want to do things like this. That's wrong. What you want to do would be to have another tag pointing at
that's
this.
there,
So this is the way to go about it. Not,
join, yes,
you understand. So this should be a reminder. Um, this is wrong. This is right. So let me share this image with you. Now I like the way the Chi method represents his own elevations. He doesn't like to just have generic text saying, "Oh, this is a window, this is a door." I believe that should be obvious to anybody reading the plan. So the best
Yeah.
way to go about elevations is after drawing your elevations, call out everything and then point at it. I will send plans for both the Kai method and the SLC method. So
And SLC.
you observe how we combine text because these are two different views in Revit, right? So how did we manage to
Okay.
use text from one elevation or one view, point
Yeah.
at elements on the other view? This is the view carrying the text, the view on the left. But what we do is
Yes.
we extend the crop region for the view on the left all the way
Yeah.
to the right, such that we could now we can now go to the sheet, position the other view for the right elevation, and then go back to the view for the other
Yes.
elevation on the left, and then
Yeah.
extend leaders.
Application.
These arrows are called leaders. Extend those leaders
Leader. Yeah, I know. Yeah.
so they point at elements on the right elevation. That way you don't have to now you know point separately on the right elevation, point separately on the left elevation. You can just combine text
Yes.
for
On the left.
both
Yes.
elevations.
Yeah.
So you are specifying everything from the shingle roof, the kind of class rating it is, class A, class B, another aspect of the roof. You are going to specify the material of the roof gutter, the fascia, the rainwater line. That's meaning of RWL, rainwater line, and then the painting to match the existing wall. So you are telling us that this rainwater line is a new one and its paint should match
Yeah.
the wall material. So if you are using white for the wall, then your downspouts or rainwater line should be painted white too. So that's what this specification is saying. Paint it to match the existing wall. But if you are using beige for your
Yeah.
exterior wall, you don't want to go and be using black or brown or some other color
Correct.
for your rainwater line. Now
It does match.
you have your window, per schedule. You point at the window, you tell us it's done per schedule, and you could go further to say TYP to tell us that okay, this is the typical representation for windows. Now when you say window with the arrow pointing to either side, you are telling us the window slides left or right. So this is a sliding window. This one is a, can you recall the name of this window? Hello, Ife.
You do the top one. The top one.
Single hung,
Top one, right? Yes.
single hung.
Okay.
Because there's just one of the panes sliding vertically.
Okay.
And now the
Yeah.
outdoor condenser unit, you point at it. The whip
Yeah,
screed.
right.
You have this thing called whip screed.
Yes.
It's usually at the joint or the point of connection between the wall and the floor. It's a detail that tells us
Okay.
how to
Right.
finish this edge.
Okay.
So that's your whip screed.
Okay.
And there's a detail sheet. So whenever we say per something slash something, we are saying per detail
Yeah.
11 on sheet A 2.1. That's the meaning of this representation. The detail number slash the sheet number to find the detail. So you are telling us that the whip screed detail is on detail 11 of sheet A 2.1. So let's see what that holds. This is A 2.1. So where's detail 11?
Yeah.
Detail 11. So this is detail 11. So this is the detail for the whip screen. You can see it clearly.
Okay.
It's
Yes. Yes.
it's
Yes.
this point of is the way you finish the edge of your stucco, and it's usually at the point of connection between the floor and the stucco finish. So this is the detail for it, and wherever you have any condition like that, you should specify the whip script and where to find that detail.
Okay.
So usually you want to have text showing the address for that ADU. When you have an ADU, it's going to have a separate address
Yeah.
from the existing main dwelling.
From the existing years, I've heard something like that. Yes.
Yeah, so you need to tell us what that address is, where it to be located, and how tall it is. Usually you want to have it to be
Okay.
4 inches high, maybe 1 inch thick strokes, and it should be visible from the public right of way or your street. Another term for your public right of way
Okay.
is your street. So the requirement is
Okay.
that wherever you put the address numeral for your ADU or your main
Yeah.
house, it should
Yeah.
be directly visible from the street access. Now you also point out LED wall sconces per plan or your exterior wall lamps. This is just another term for your exterior wall lamps. LED wall sconce per plan. Now also your
Okay.
doors should be indicated per schedule. It could also be
Your
typical.
what? Your dogs.
Your doors,
Your
yes,
dogs,
point at
right?
them and say per schedule. Then your step, you would have a step that leads from the finished grade to the floor level. That too should be basically you are annotating every element on your elevation. If you don't have the text annotation for it, do the research, ask questions, and I'll provide that information.
Okay.
But
Alright.
also your electrical panel should be labeled. You see, new electrical sub panel which is 100 amps. So
Yeah.
this is the best way to represent elevations. Now sections. For sections, we basically draw our sections normally, how we draw sections now. But note the foundation type you are
Yeah.
using. You must know that information before you go into your design. You must know what foundation type is being used.
It's doing you.
Yes, if you're having a slab on grade,
Okay.
if you're having a slab on grade foundation, you are going to show the edge beams. Alright, this is the way you draw out the slab on grade
Edge
foundation.
what?
Edge
The edge
beams.
what? I didn't get that.
Edge beams.
Okay.
Edge
Okay.
beams.
Okay.
So these are, or you call them
Yeah.
ground beams. That's another term for them.
Yeah.
Edge beams, ground beams. So it's usually the thickened end of your foundation, of your slab on grade foundation. And you can
Yeah.
notice the height varies. Sometimes you have the slab on grade to be more than 1 foot from the grade, or you could have it directly on the grade or 1 inch from the grade. That depends on your design. You must also show what you call your insulation, your wall insulation. Those must be shown too. Usually you only insulate the exterior
Okay.
walls. You only insulate the exterior walls, and then your roof. Your roof needs to be insulated too. If you have a vaulted ceiling, then you are insulating the roof itself. But if you have a normal height ceiling, then you are insulating the ceiling and not the roof. I would explain.
Okay.
Um,
I think I get you. I think I get you.
yeah, for the purpose of others, I'll be going through the videos. Let's explain. So if you have your wall and your roof,
Yeah.
and let's say you had the section shape to be like this. Let me draw another one here. Let's say you had this. Now one of them has the ceiling to be horizontal. The other one has the ceiling
Yeah.
to be flushing directly with the
Following
rafters.
the rule with the rafter, yeah.
So let me just show the floor. This is the floor. And of course, if you have, let's say we had slab on grade here. Now, one thing to note is this one is your normal ceiling.
Okay.
While this is your vaulted ceiling.
Yeah.
Now, your normal ceiling is usually at a height of 8 feet above floor level. This is the minimum height for a standard room size. It needs to be at least 8
Okay.
feet from floor level.
8 feet.
So the main difference between the normal ceiling and the vaulted ceiling is your normal ceiling, the ceiling is horizontal. Your vaulted ceiling, the ceiling is aligned to the rafters. This is the rafters,
Will be rafters. Yes.
and
I
this
know.
is this is
I know. I
yeah.
know.
I'm explaining for others that may be going through the videos. I know you know these things.
Yeah.
So
Okay.
now I want to explain insulation, right? So
Yeah.
when you have insulation, you typically have them on the exterior walls. That's what I've represented. Don't mind my schedule. So you
Okay.
want to have them mainly first. Your exterior walls must be insulated. It's thermal insulation. In addition, if you have a suspended floor, it's going to be insulated too. But if you have slab on grade, you are not insulating concrete. Now, in the case where you have a normal ceiling, it's that ceiling that you will insulate. It's the ceiling you will insulate. But where you have a vaulted ceiling, it's the
Okay.
roof that you are going to insulate.
That you will see. Okay.
Now, there are some peculiar situations which I would just run through. Let's say we had a skylight on a mono pitch roof. Let's say we had a mono pitch roof.
Yeah.
Let's say we had the skylight here, right? This is where we designed the skylight. And let's say we had a room here,
Yeah.
and we had another room here. Let's say the skylight was on the hallway, right? Now,
Yeah.
let's say you had a ceiling here, which is 8 feet from ground level, another horizontal ceiling here, but the hallway is vaulted. You see the difference, right? Now, the way to do the
Yes.
insulation on when you have a situation like this is, of course, in all cases, we're always going to insulate the exterior walls. Also, now you're going to insulate those rooms that have horizontal ceilings. You are going to insulate their ceilings. Now you are going to insulate this portion of the wall that is above the horizontal ceiling, and you're also going to insulate the roof. So this is the way to go about. There are many times when you encounter situations like this. In such a scenario where you
Okay.
have you have a vaulted ceiling in the hallway or some other space, and the adjacent spaces have horizontal ceilings, that this is how you do it. You insulate the ceiling to a part of the wall, you insulate the roof itself, and then the ceiling. Some other times, the Kai method could also say insulate the wall all the way down. So you'll be
Okay.
finding lots of insulated areas, and that's why we had this kind of section here. It's because somewhere along this mono pitch we have skylight, and because of that we had to insulate several interior walls, because your skylight will also admit heat into the space, so you want to be able to protect the adjacent spaces that don't have that skylight opening.
Yeah.
Now another situation is if you have your normal suspended floor, and this this goes all the way to the foundation. These are normal concrete. Now, this is timber, right? And you have your seal plate here, and you have your crawl space. Yeah, remember crawl space is going to be 18 inches below grade, or below floor surface rather. So let's see.
No,
Yes?
no.
Yes, I'm with you.
Can you give me a minute? I need to eat myself. I need to eat.
Okay, fine.
I'm back. I don't.
So, I was trying to show, in the case where you have a crawl space, how do you go about the installation?
It's making the space, right? The floor.
Yes,
Or what?
yes. You are going to insulate the floor because this is not slab on
Yeah,
grade.
yeah. Well, what I do is, like they did in the drawing, what I did is I just insulate the floor directly, yes.
You are going to insulate the floor.
Yes.
But this only applies for when you have a crawl space. So if you are doing slab on grade and you have concrete,
I know.
you cannot insulate it
I
too.
know.
So
Yes, I know. Alright.
that's for insulation, and I'm emphasizing this for the sake of others
Others.
who would watch this video. Of course, this is your finished grade.
Yeah.
Okay. So back to what were we looking at? Insulation, right? Sections. So that's for installations, and of course you show your earth finish, you label out all the elements, you tell us the kind of installation you are using. So usually the Title 24 document would specify the installation to use based on the analysis, right? So yours is to say these walls, these roofs, they would have the installation per Title 24. This T24 means Title 24. So you are saying we're going to have the installation to be per Title 24. Now roof rafters, we are saying would be new, and then the reader, the contractor, whoever is looking at the drawing, should refer to the structural drawings. That's the meaning of SSD.
Yeah.
C structural drawings, or C structural documents. Yes.
Okay.
Now you're going to point out every other thing so people don't assume. For instance, if I'm seeing this, I'm not sure what it means. But if the architect has said this is an indoor AC unit, then I can now make sense of what I'm looking at. Point out the fascia board, point out of course, any reference to insulation must be with regards to the Title 24, which we abbreviate as T24. So you're going to tell us the stucco will be 3 paints. If it's a new stucco finish you are doing, then you need to specify it in full.
Yeah.
But if it's an existing wall finish, then you just say E in brackets existing stucco. You don't need to tell us it's 3 coats, it's over a metal latch with 2 layers building paper and all that. Just tell us stucco 3 coats. And then in the case where you have slab on grade, you show concrete footing. If you have suspended floor, of course you can show concrete footing. And then we have all these box notes going on our sheet specifying other things that we may or may not have included on the sheet notes. For instance, address numerals.
What?
We are specifying the requirements for the address numerals. You know what I'm referring to as address numerals? This address number for the house.
Yeah, okay.
That's the address numeral. So we are specifying its requirements in this boxed note. And we are saying provide signage or numbering on the main home indicating the presence of an ADU. Signage it should indicate 6400 as the ADU address. So we are saying that that's the value that should be indicated for the ADU. This box note is saying exterior stucco to match existing main dwelling, of course. Now we are going further to state further requirements about the address numbers. We are saying the address numbers shall be internally or externally lit during non-daylight hours. So at night, that numbering should have some kind of lighting that emphasizes it for the sake of someone trying to locate the house. Now, it must be on at all times. That's the lighting must always be on.
The address,
Yes. So, switching shall be controlled by a time clock or a photo sensor battery or photo cell powered unit cannot be used for required addressing. So there must be a photo sensor or some kind of feature that detects daylighting. So if inbuilt into
yeah,
the address, you have a lighting fixture that can detect when there's sunlight and when there's no sunlight. Then such a feature can control the intensity of the lighting. If it's very dark at night, it
okay,
maximizes the lighting, and if it's during the daytime where the sunlight is up, it turns off the lighting completely. It's kind of like occupancy sensor, but this one is a photo sensor. It's not detecting the presence of people. It's detecting
of
the
people,
presence
yeah,
of light on the exterior. So
okay,
you have address numbers, which should be at least 4 inches high and installed on a contrasting background. So when you have an address number that you are indicating, there should be contrast between that number and the wall surface or whatever background you are placing the number on. It should be the contrast ensures
yeah,
that
yeah,
it's readable from a distance. Now, address numbers shall be read from left to right. Vertically positioned number cannot be used. So we are saying
okay,
the address number should be left to right and not vertically positioned. So address numbers shall be placed in such a location that emergency crews can read the address from the street fronting the building. What I explained earlier, it should be visible directly
yeah.
from
There are
the
people
right of
from
way.
Mozambique, yeah, I get it, yeah,
Yes, so we also
yeah,
have our door and window schedules. We are showing the width, the height, the mark, and then additional comments. The comments could be relative to the space where the door will be used, or the kind of operation, or the material of the door. All that information will
yeah,
be indicated on the schedule. So, and then we have our detail sheets. We like to arrange our details on grids. There are generic details that you can put on the sheet, and sometimes there are custom details you need to add. So it's left to you
depending on the
to
project, yeah,
know the requirements of the project and to know which details are relevant to
yeah,
the scope of work. Some of these ones
yeah,
are aging in place requirements. You have to provide
yeah,
blocking for grab bars in the future. If the concept is, if you have an occupant in this house and you expect them to spend the rest of their life in that house at an older
yeah,
age, how do you ensure that the features can be upgraded without having to break down any walls? For instance, when someone ages, they need support in their bathroom. There need to be
yeah,
grab bars in the bathroom, right? So
yeah,
if you are going to anticipate the use of grab bars in the future, right now when designing the building, you should provide what they call blocking in the structure of the walls.
alright,
So between your wall studs, you are not providing the grab bars now, but within the structure, these are
yeah,
your
for the
studs.
future,
Yeah, you are going to have wooden blocking between each stud at this particular height above floor level, and
yeah,
sized according to the structural engineer, but there are common sizes that you can use. And then, so all these details shows us the need to provide blocking on the floor plan. Some other city may tell you to show what sections or segments of the wall you are going to be providing that blocking.
okay,
So what you would do in
Wow.
such a, have I sent you this image?
Yes, you sent me the information. I have it.
Okay. So what you are going to do in
Yeah.
such a scenario is you are going to show like some line patterns either next to the wall or within the wall. And if I were
Okay.
to show those sections of the wall where I would provide blocking, then these are the sections I would show it. Not the full length of the bathroom, but right behind the WC and all around the shower. Those are the areas where you provide the blocking for your grab bars. And then you're going to go on your legend and tell us what this line represents. So you say obviously grab bar blocking, provide maybe 2x8 blocking for future grab bar installation. That would likely be the
Yeah.
text you will have next to the legend.
Yes.
And then you can have additional boxed notes. This is what I'm referring to as box notes, all these boxes with notes. You can have
Yes.
additional box
Yeah.
notes specifying aging in place
Yeah.
compliance. So new constructed dwelling units, including detached ADs, are required to comply with aging in place. You can go further to say
Yeah.
electrical receptacle outlets, switches, and controls intended to be used by occupants shall be located no more than 48 inches measured from the top of the outlet box and not less than 15 inches measured from the bottom of the outlet box above finished floor. So you are even limiting the height of your switches and other controls because as someone gets older they cannot be
Yeah.
stretching to control one light fixture, so it shouldn't be more than 48 inches and it shouldn't be less than 15 inches from your floor surface. Additional aging in place specification, provide 2x8 wood blocking. We've talked about the blocking between wall studs at 33 to 36 inches above finished floor. To provide reinforcement for grab bars behind and beside the toilet, the grab bars must support a minimum of 250 pounds of force applied in any direction. That's the specification for the blocking. Next one is install 2x8
Okay.
horizontal wood blocking along the bathtub. Remember I said it's going to be along the shower or bathtub. And lastly, install 2x8 wood
Yes.
blocking between floor joists for future grab bar floor installation. So of course you know that you have some grab bars that are floor hosted, right?
Yeah. Yeah.
Those ones are common between your WC and your shower. You have things like this. So these are floor hosted. So the one that is wall hosted, remember we've provided blocking here, right? Now the floor hosted
Yeah.
blocking, will be here between your floor joist. Remind me to talk about floor joist direction later before the end of the call.
Okay.
But so
Alright.
aging in place involves details, specifications, and you have to add all of that information. Then usually on the final sheet we tend to have title 24. My client has a consultant who does title 24. So usually they send me the document and I add it to the package. Now we also have the specification sheets for skylight. We like to specify Velox for skylight, and then we like to specify GAF for roof shingles, asphalt roof shingles. So we also have Cal Green compliance sheets. These ones are, we always have to add them. Then
Yeah,
we've
no
gone
problem.
over cover sheet. Now ventilation calculation and what's the last one? Floor joist, floor and roof joist. So let me explain floor and roof joist before ventilation calculation. So let's say you had let's say you had a mono pitch roof,
Yeah.
or let's say you had a normal gable roof. Let's say you had this. Of course, you know these are your rafters, right? And you have let's see it in
Yeah.
3D like this. Let's say this was your gable. Now you are going to, these rafters are solid timber members. Because most people they just draw it in 2D, but they do not know how to, make sense of it. Because on some sections you are supposed to be showing
Yeah.
section cuts through your rafters, right? So this is how you can explain
Yeah.
it. You have what you call your ridge beam. This is your ridge beam, and then you
At the
have
top
all,
of, yeah.
yes, you have
Yeah.
all these rafters at a particular spacing.
Yeah.
Now, if you were to cut a section in this direction, let's call this section A, and then you cut another section to this direction. Let's call this section B, right? Now, if you were to
Yeah.
draw section AA, what you would see is this. Right? This section
Yes. Yes.
AA.
Yeah.
And then if you were to
Yeah.
cut section
Yeah.
BB, what you would see is this. So you're going to be having, now this is what I really want to emphasize. Some of the rafters will be shown. Because some other person may just cut it and not bother about how the rafters should be
Yeah.
shown. So you're going to show, your wall.
So let's confirm how we follow this.
Okay. So you're meant to, think, understand the orientation of the rafters, and then show the rafters in section accordingly. I will show you a component
Yeah.
on Revit that we use to do it. We don't like to use manual, what is it called? Mask regions.
You do it.
Before I used to use mask regions, but Kai introduced me to one component he used to use, and that's a more efficient way of
Yeah.
going about it. While it's saving, let me continue. So remember, we are going to be showing now on the section that shows the ridge beam. You are going to show the ridge beam. We
Yeah.
are going to show wall plates, top, seal height, sole height, and all the members. I'm going to draw a larger section through the wall. So let's say we had a condition like this, and then we have our wall. And then let's say we had the suspended floor, and then we have the foundation. Now, the way to draw this is you're supposed to have members. Let me use another color for that. You're supposed to have members, and they all have to be shown.
Okay.
So this is wood. going to have another wood here. Note the way they are oriented. Now you're going to have, let's say you had a window here. Let's say you had a window here. This is critically important for our sections. But sometimes some people draw sections and I'm like, bro, what the heck is this? So this needs to be paid attention to. So you have now you need to show the header, what we call lintel, but if you are dealing with timber structures, we refer to it as the header. So that header goes over openings. Say you are cutting through a window or a door, you have to show that header. You have to show the base of your window sill. There's also another member here, right? There's another member here. Now for your wall plates, you know, this is your rafter. Your wall plates now, you first of all, before your wall plates, you have your top plates. So this is your top plate, and then your wall plates. This must be shown like this. Now your ceiling, of course, you know your ceiling goes this direction, and even your ceiling, there's another layer of gypsum board. This is the ceiling joist. But this is the usually half an inch gypsum wall board. Now, what I want to emphasize is the way this thing should be drawn, right? You need to have all these members on a typical section. You need to show them. Now, you need to show or label them, of course, and you need to know their typical dimensions, right? So for this one, you could have this to be like 4 by maybe 8 or 10 or 12. It's the structural engineer's job to determine the size of the headers, but you must represent them on your drawings. Usually you have these ones to be typically 2 by 4 inch seals. Likewise, the sole plate. This is the sole plate. Sole plate.
Bottom one.
Yes.
Yeah.
And you want to call these 2 by maybe 2 by 4, of course. If you are dealing with a 6-inch wall, it's going to be 2 by 6, not 2 by 4. Now this is your rim joist or your floor joist, and this could be 2 by 8. Of course, the structural engineer's job to size it. Now, there are still some members I've not shown. Your floor joists have to be shown, depending on the direction. This is not always the case. In some cases, you would not show the floor joist in section, and in some other cases, you will show it in section, depending on the direction you are cutting.
Through.
Yes. So let me see if I can. Let's say you had your floor layout to be like this. Let's say this was your floor. Okay, I will still talk about floor joist direction, but just know that you have to show the floor joist depending on the direction you are cutting the section. And the usual dimension is, they are usually 16 inches apart, or 16 inches objects centers or on centers. Now your rafters could be maybe 24 inches on centers, but it's also the structural engineer's job to determine the sizing and spacing. So, but basically be be sensitive to the direction in which you are cutting, and then
Yes.
how you are
Cutting through.
supposed to show the members in that section. So I want to
Yes.
also mention something. You have nominal size, and then you have actual
Okay.
size for each of your members. You have
Yeah.
you have nominal size,
And we have actual size.
and then you have actual
Size.
size for members.
Yes.
Now you have let's say you have 2 by 4, 2 by 6, 4 by 4, 4 by 6. Of course, the nominal size is 2 by 4, 2 by 6, and so on and so forth. But the actual size is, can you guess? You are going to be subtracting half an inch from all the dimensions.
Okay. Half an inch, right?
Yes.
Okay.
So if you have a member that is quoted as 2 by 4, you should know that the actual size is 1.5 inches by
1.5 by
3.5 inches, and that's the actual dimension you are going to use when drawing the section. You understand? Not
okay.
not the full
Yes.
2 by 4 that is being quoted, because that's the nominal size. It's in name only, but the actual size is usually half an inch less than the nominal size. So let me share you this image just for your just as a reminder, basically. Now I want to talk
Okay.
about the floor joist directions, because that's also very important. For your floor joists, if you had a floor
Yes.
like this, and you have your joists to be oriented like this, let's assume this was how the joists were oriented. Don't mind my sketch. I'm sketching with my mouse, so I don't have a proper sketching device. So, well, basically, you get the idea. These are the these are the joists, right? And this is the floor. Now, if you were cutting a section through this, let's say we're cutting in this direction. Let's call this A, and we're also cutting in this direction. Let's call this B, B. So when you are drawing the floor for section AA, you are going to show each member in cut. Section BB, you are only going to show the edge in cut. So this is how would this be done? For section AA, of course, both of them must have an edge beam or edge joist. Now, for AA, you are going to be showing all those members in cut. Because think of it visually, if you are slicing this and you are looking in this direction, you are going to be seeing all these members in cut. In any drawing, if you ever have a member shown as X, it means that's a wooden member that is being cut through. But section BB would not have those intervening joist. It's just going to be plain, but you must have the edge joist. Ife, are you there? Hello?
Yeah, I agree with you. I agree with you.
So this is section.
Hey.
You don't tire, Abi? Yeah,
No, I
the
agree
call
with
is
you.
almost 4 hours actually. So we've actually tried. I believe
I
we've
agree with
covered
you.
a whole lot of things
Yeah.
with the call now, and now you'll be better equipped to working on Karen.
Mm-hmm.
We'll just brush through Karen
Yeah.
to just note some things.
For the missing part, yes.
Yes,
Yes.
and then I'm sure you'll be able to finalize that in no time. But usually we know these sections, these distances to be like 16 inches, center to center.
Yes.
So
Mm-hmm.
like 16 inches. So that's for floor joist. What's left? What's left? What's left? Okay, I believe I've covered ground. There's nothing left. So let's just dive right into
Go
Karen
back
and
to
yeah,
Karen, I think.
yeah. So now I was looking at this. The existing and demo site plan has no issues other than the fact that this was crossing through the borderline, so you have to crop it down a bit so that line would not go past the borderline. Then now you
What
understand
part is that? I didn't see that.
this center line up here for Grima Boulevard, this street. You had this line extending beyond the
Okay,
borderline,
okay,
so crop it down a bit
okay,
so it doesn't extend into
okay.
the borderline.
Alright.
So whenever you are doing a site plan, you see VIF under a dimension line, you are basically telling us to verify in field that dimension. That VIF is an abbreviation for verify in field. So sometimes you want to
Okay,
indicate that
verify in field.
you want to indicate that below the dimension string. You want to write VIF next to all of these. Then
Chief, I'm sorry.
okay.
The VIF next to, is it all the
Yes, all the dimensions, all the
this thing,
property line
all
dimensions.
the side boundaries, property lines, dimensions?
Yes,
Okay.
remember this PL
Okay.
is the symbol for property line. This one.
Yes,
Now
yes, I know.
you understand better what this slope means, right? It means that you are grading
Yes.
the site away from the building to slope towards the street,
From the
and the
yes,
2% applies to
yes,
your hardscape, while 5% applies to
yes.
your
5
softscape.
to the top two.
Yes. Remember how to set
Yes.
phasing such that you see existing and demo to be hatched in red or some other
Yes.
pattern. Remember to show your
Yes.
electric
Yes.
meter.
Yes.
Now this electric meter should not be shown as new, because you need to be very critical and detail oriented. If you are looking at this plant, you need to actually look at everything, every single element. For instance, this is
Okay.
this is a site plan
Yeah.
that shows
I
the
see.
existing and demo.
Yes.
This should not
Yes.
be there because you are showing the new electric meter.
Yes.
This belongs to your proposed site plan.
The next one.
Yes, so not
yes,
here.
Yes. Yes. That's yes.
So you may not need to do this. You may not need to do this. Front is enough. We're okay with the ones in front.
Which one? You're deleting dimension.
Yeah,
That's
those
deleting dimension.
yes, those ones that
Okay, that's from the front. At the back, at the rear.
yes. You don't need to show those ones.
Okay.
Then threes. I will share you one or two projects that we did in the Kai method, so that will help you to see
Okay.
some of the things we also annotate on site plan. If you have an
Okay.
electric meter, this is not always the case. It's not always 125 amps. The default is usually 200 amps. But if
Okay.
you are not told, ask me that, guy Alpha, what's the capacity for your electrical panel, and I will look for the information and get back to you.
Okay.
But by all means, show details, show information, and do everything intentionally. Don't just add any random notes thinking it belongs to the site plan. For instance, I'm not seeing the position of the air conditioning. Okay, yes, we have an air conditioning, but it was not labeled,
Yeah.
right? You did not tell us it's an outdoor condenser
Okay.
unit.
Yeah.
You did not tell us where the electrical panel is. Not tell us where the meter is. Okay, we know where the meter is. You did not tell us where the overhead electrical cable is. I didn't even tell us the distance of this setback. It was just shown, but there is no dimension line that tells us what this setback distance is. Nor is there any text that identifies that distance.
Okay.
So that needs to be shown too. Like this one that we showed, 5 feet. Did you verify that the setback is
Yeah.
5 feet? Also, you should indicate that distance. And when you are indicating distances, please pay attention to the text size you are using. And that way, what you need to do is to
Okay.
study the sample or reference project I will provide to you or have provided to you. So you use the appropriate text type for that thing you are trying to label. So don't just use any random text for anything. It should be based on what the references use. Now this shows project data, existing and demolition site plan. Now one thing I noticed you doing, you now went to the next sheet, which is supposed to be a proposed site plan, but you did not update the sheet title. You currently have existing and demolition site plan,
Existing and demolition.
and that should not be the case. Also, you have your project data again. You don't need this on more than one sheet. It's just needed on the cover page, and you don't need to fill up every sheet. So you can just delete. You don't need this. You don't, this is fine. This is perfectly fine. If this is all the drawing you have on this sheet. You remember, we like to have this on the left, but because we have all this space, you can put this near here. When there is no north arrow, you need to indicate your north arrow. It needs to be towards the direction of the north. You see what I'm talking about? This line crossing through the border, that needs to be addressed too. You need to label everything. You need a legend. You need a site plan legend to tell us the meaning of all these hatches. I'm seeing two types of hatches. So you need to, copy this legend and place on this other one. This same legend applies here. And in the case where you're adding more kinds of hatches to the site plan, then what you have to do is edit this hatch. So you add a new hatch pattern and add the information there. If I are supposed to edit this one and tell us this is new addition, the one that is cross hatch, the single hatch, they're telling us this is the remodeled area of the existing house. Also, one thing I noticed you doing is making these two lines to be thick. No, we like to have this thick, and then we like to have them 0.1 inch apart. That's the distance, not just any random spacing. These two lines.
The distance between those two lines.
Yeah, we like to have them 0.1 inch apart. And then one is thick, one is thin. The one outside is thick, the one inside is thin. So bear that in mind.
Can you do that too? I need to get something in that way.
I'm with you.
First, so, zoom in, please. Can you zoom in? There. Zoom into the line, please. Let's verify that.
Okay, this is profile 4.
In mind, I'm having this line.
And you can always delete it and draw another line. It's not cast in stone. You can always delete it and you are free to delete and add anything you want.
Dimension, can you give me the dimension again? Let me see.
0.1 inches. Select one, then adjust the witness line so you point at the other one, then click the value and type 0.1, and then your quote symbol. Your quote symbol tells you inches, and then enter.
I know. For the inches,
Yes. Another thing I noticed here is there's just one drawing, so this should not be 2. This should be 1, because that's the first drawing on the sheet. The first and only drawing.
Which one?
The detailed number of the existing and demolition site plan. It should be 1, not 2.
Yeah.
Also, the length of
detail
the length
number.
of this demolition site plan, adjust it so it just go a bit beyond the text.
Okay.
You shouldn't have things like this where graphic scale is clashing with your north arrow. You also need to ascertain the north arrow direction is the right direction. You know how to do that from
Okay.
Google Maps, right?
Yeah. Just
Okay, for the purpose of
rotate, go to the beginning now. Yeah, I know.
okay, but for the sake of others,
Yeah. In fact, okay, yes. Right. Let's go and think from that.
let me search the address. What I do is I copy the address from here. And
Yeah.
this should show the address, not VR Tulip. I don't know why this is the address. No, it's not even Vanderbilt. It's Karen. The address is
Okay.
4473 Karen Street. So you need to go over this information, Ife. Based on what we've discussed
Okay.
earlier, you need to go over this
Yeah.
project data and then update them to the right values, including the address.
Yeah.
So the right address should be shown here
Okay.
and even on the title panel. Also, you need to verify the adjacent
Okay.
properties. Although I think I searched Google Maps to determine the adjacent property. So let's check the adjacent one. I don't want what is it called? Street view. So the way to determine north arrow is first switch to satellite view. And then zoom in. This is the site you are working with. 4473 Karen Street. Now see the way the building is oriented. The north arrow is here. So
Yeah.
one thing you could do is take a screenshot and then rotate this relative to the building. And then when you do that, you will find the north arrow pointing towards this direction. What I mean is this. This is the building outline, right?
Yeah.
What I will do is on Google Maps, the north arrow is already by default towards the top.
Yeah.
So your north arrow is already here. So what I will do is I will now take this outline and rotate everything approximately. So if we have this situation, right? Let's say we had
Yeah.
so we had this. Now if we rotate this, basically what we are doing is rotating this.
Yeah.
So if it's oriented vertically now, what happens to the north arrow? The north arrow rotates
It moves, it rotates
slightly
Yeah,
towards
towards the right.
this direction.
Yeah.
So this helps you estimate it. So when you are doing your north arrow, you rotate it so it conforms with it. It may not be an exactly precise value, but you can visually
Yeah,
estimate
value,
it
yeah.
and update accordingly.
How about this thing? I want to can I ask something here?
Yes, go ahead.
In this case now, this case of rotation,
Yeah,
definitely the distance has been affected the degree, right? You
Of
rotated
course.
it through a degree, right?
yes, of course.
So are we putting it there? Are we
No,
putting
no,
it
you are not
in
indicating
degree
it
there?
because
I
we
mean,
don't have a precise
just
survey
the arrow.
plan, but you want to estimate the
Okay,
general
okay.
direction.
With the arrow.
So that
Alright.
helps us show the north arrow. Now remember I said north arrows
Alright.
for the SLC method towards the bottom right of the screen. So you shouldn't have the graphic scale intersecting the north arrow.
Yes. Inter.
So you could now the graphic scale too. It's not always the same thing for every drawing because the scale has to
Okay.
be adjusted. The way to adjust the scale to your need is there is a scale factor to this component, this detail
Yeah.
component. So if you are drawing a site plan at scale 1/8 to 1 foot, the scale factor is 96. If you are drawing it to scale 1/4 inches to 1 foot, the scale factor is 48. So it changes to 1/4. These are the standard scales. If you are drawing to any
Okay.
larger scale, you basically be multiplying by 2. You understand? Multiply by 2 every time.
Yes.
48 times 2, 96. 96 times 2 gives you the next scale, and so on and so forth. So if you are adding this graphic scale to your floor plan, the scale factor is going to be 48 and not 96 because your floor plan scale is 1/4 inch to 1 foot. So moving on, you are going to add the legend here and rename this to proposed site plan. You are going to add text. Be free with text. Don't be too restrictive. You are going to say this is the existing garage because that's actually where the existing garage is. And that new addition area that
Okay.
is hatched as X, you are going to
At a different depth.
you are going to call that new addition. You know, so that's you annotate your new addition, you annotate your existing, you know, where you have your chimney, you point at it. In fact, you need to be looking at this thing in detail. You know, this is a planter now. You could as well point at this and say existing planter. You know, your air conditioner, existing
Yeah.
outdoor condenser units, concrete paving, or paver stones, or whatever it is you are using. Existing pool, pavers, landscape, no modification. You know,
No modification, I guess.
um, just detail and annotate everything basically. So that's for existing and demolition site plan, proposed site plan. Now existing and demolition floor plan, like we went over the other plan, you are supposed to
Yes.
look for the appropriate sheet notes. Now the Kai method has keynotes and sheet notes. This should be keynotes, they are generic. But sheet notes will now be okay, remove existing counter, remove existing door, provide infill walls. Remember those
Yes.
notes we went over earlier. So you're going to be providing them
Yes.
and pointing at each element to be removed or added. On your floor plans, you do not want to show site elements. So all these site paving, all these what do you call them? Your shared structures and everything, they will be hidden from view. Only your floor plan, even this your
From here, yes.
even this
Okay.
your pavement should be hidden from view. Only your floor,
Yes.
only your building outline should be visible here. Proposed floor plan, you're going to show the proposed as well. Um, you also do not want to show the paving and other site features here. So of course, before you even go into the drawing, you must understand what's really happening in terms of the scope of work. You know what we are doing, like I explained to you in the last
Okay.
call we had, is we are demolishing some parts of the roof, some interior spaces, some walls, and we are adding a new family bathroom and a new kitchen, and then we are adding a new porch.
Yes.
That's the scope of work. So nothing concern
Okay.
garage. So bear that in mind while you detail this. Remember to annotate everything. Point at sinks, cookers, all the sheet notes. You know, all those things should be carefully documented. And then your elevation tags. That's also another important thing. Make sure that the elevation tags for existing and demolition plans are the existing and demolition elevations. You know what I mean? If you have, man, I don't want to talk. If you have, God, if you have your tags for existing and
Yeah.
demolition, yeah, thanks.
Yeah.
Existing and demolition
Yeah.
floor plan. Make sure that this tag is for an existing and demolition elevation. So
Elevation.
this is a proposed elevation. So
Okay.
that's not right. The tag shown here should be existing and demolition. So you hide from view those ones that refer to existing and demolition elevation, and then you retain in view the ones that points to the existing and demo.
Okay.
So what I'm saying is your existing and demolition floor plans should only show
Yes.
existing and demolition
Tag.
elevation tags.
Yeah.
Now proposed
Yeah.
floor plans. Proposed floor plans.
Wait.
Okay, I'm with you.
I have a question. I have a question for that. I have
Okay.
a question for that. I'm pretty confused. Now, I'm in my existing and demolition floor plan now. Can you tell me?
I'm with you.
Yeah, I'm in my existing and demolition floor plan now. Now, the elevation tags on that floor plan, if I try to get you, I think those elevation tags must be leading to existing and demolition elevation.
Correct. Correct.
Yes. How do you know that the tags on this?
Okay, good question. How do you know the tags visible on the
Yeah.
floor plan refers to either the existing
Yeah,
or the proposed?
Yeah.
Good question. So the way to do that is, first off, when modeling, I
Yeah.
I just have everything to be visible everywhere. Then when I now want to start documenting, I start to rename, duplicate, set the face filters. So you should be conscious of that when you currently have only 4 elevations. Are you with me? When you currently have
Yeah.
only 4
Yeah.
elevations, what you should do
Yeah.
is you should hide on your existing and demolition. The elevations you would first do should be existing and demolition elevations. You understand?
Okay.
So now you duplicate
Yeah.
those elevations, and then before you
Yeah.
paste the elevations, you should hide all the elevations that have been drawn in view. So you are left with no elevation tags, and then you paste the
Yeah.
new elevation, and then you can now start to rename them directly on the floor plan. What do I mean? For this one now, I'm going to delete all the elevations because obviously you have another file on your end. But this is the concept.
Yeah.
Delete all the elevations. So all the tags and all the elevation tags should be deleted as well. Right? Now I don't have any elevations.
Yeah.
Now,
Yeah.
let's say I wanted to now start adding elevations. I'll go to my view, go to elevations, click elevations, and then I want to create the first elevation.
Yeah.
So I'll put this here, create the second elevation, put this here, create the third elevation, put it here, and the
Yeah.
fourth elevation, put it here. Of course, you want to adjust
Mhm.
the extent of your elevations. So you are going to
Of
be
the elevation. Yeah.
selecting the arrow, then modifying the extent. Make sure it covers the building you are showing the elevation.
Full length of the building.
Yes, so it shows all the sides of the building. So I'm going to be doing that for all 4 elevations. This one is not properly oriented. It's slightly skewed. So we are going to add another elevation tag to make sure you drag the elevation tag next to the wall. So it's it's not at an angle. You make sure it's oriented to the wall by dragging it close enough to the wall. And when you position it, you can always drag that elevation tag to the position you want it because it's already oriented
Yeah.
in the right direction. Then
Yeah.
you drag the extent. Now when you set the extent, you can now start to rename, right? So what I do is,
Okay.
of course there's a pattern for how they should be named. You can check the file for your end from your end to see how I like to name them. Fronts. Also you show the cardinal in brackets, existing and but I will just use the basic existing and demolition elevation. So when you select the
Okay.
arrow, right? When you click
Yes.
this arrow on
Yes.
your properties palette, you will scroll to view name. You are going to see the name of that elevation.
Yes.
So you are going to click it and rename it to what you want. So I want to call this existing and demolition elevation or front elevation. Oh no, the way I like to do it, front elevation hyphen existing and demo. So it should be and demo, not 7. So you do that for these two. This one will be right, Abby. Right
Yes.
side elevation should be existing and demo. You do that for the rear. I think this rear elevation is okay, is oriented properly. So the rear would be rear elevation hyphen existing and demo. Then the left will be left side elevation hyphen existing and demo. Now that we've done all the existing, of course, in order to ensure that those elevations are what do you call them, existing and demo, you have to double click to enter the elevation and
Yes.
check the phase
The
setting as we
elevation. Yes.
mentioned. If you have a view that is existing and demo, your phase is always new construction and your phase filter is always show previous plus demo.
Show previous.
Now you're going to hide in view your section lines. We don't like to show them on elevations. Also,
Yes.
turn off your
Yes.
crop region, change your levels to what do you call them, halftone, and then you can hide some of the site.
Okay.
You can hide some of the site elements, and you can choose to leave them.
Element. Yes.
It's all dependent on your own, graphical sensibilities. But basically, you are going to be setting all the other existing and demolition elevations. Now, in order to provide a proposed floor plan, right? The way to propose
Yes.
elevation tags now. This one's shown on both plans are existing and demo. What I will do is
Yes. Yes.
select the tags for all. Go to the proposed floor plan. Then select the tags for all the proposed elevations or all the existing and demolition elevations we did previously.
Elevation. Yes. Yes.
Now what you will do next, while they are selected, you come into your clipboard, click copy to clipboard, then click this arrow drop down.
Okay.
Before you click paste, make sure you've copied to clipboard while they are selected. Now you select them again.
Okay.
You select them again. Because remember you are on proposed floor plan, you are not on existing and demolition
Yes,
floor
yes.
plan.
Yes.
So while on proposed floor plan, you will come and hide these ones from view. On your proposed floor plan, hide in view. Element, not category. Now you go to modify and click paste aligned to same place. To paste those tags that we copied to clipboard earlier. Do you understand?
Yes.
So now when you go to your elevations list, you see that new elevations have appeared. These were the existing and proposed elevations we did. Now new elevations have appeared. But one thing we forgot to do was to rename some of these views.
Okay.
This is the rear. But of course you would have, let's say rear sharp. Let's use a basic description. This would be, this one would be right. This would be right. Now, one thing you will notice on Revit is that all the duplicates will be carrying 1 next to them. right?
Yeah, yeah,
Wait, before
yeah.
we even paste aligned, let's rename these two accordingly so you don't confuse them. So I've undone the changes back to when we're renaming existing and demolition. So this one
Yeah.
would be existing. No, this would be, what do you call this? Right elevation.
Mm-hmm. Position. Yeah.
Existing and demo. And then this would be, what's this? Rare. This should be rare. Remember to always hide by category, drag your
Yeah.
levels, change to halftone and all that.
Yeah.
But this is your rare elevation, existing and demolition or demo. Now let's go back to our existing and demolition floor plan and copy those elevation tags again.
Again.
Well, in order not to unintentionally select other elements, it's good to just pick them one by one. Now when they are selected, you click copy to clipboard. While they are still selected,
Yeah.
you go to your proposed floor plan. While those tags are still selected, remember we've copied them to clipboard. We are going to hide
Yeah.
them in view. But because they are hidden already, then I don't need to repeat that step. But if they were still visible, you will hide them in view.
Yeah.
Now, now you are going to paste those tags you copied to clipboard earlier, align to same place. So now new elevations will appear on your elevation browser and they're all carrying 111. So these are the duplicates.
Yeah.
So what you do is just rename them. This one's carrying 1 will now be proposed. Have you?
Yeah.
So it will now be proposed. You just copy out, cut the last piece of text from existing and demo all the way to 1 and then rename it to proposed. So you do that for all the others. Now, when you do this, you know all these views are duplicates of the existing and demo. So you are going to make sure that the face filter for the proposed elevations, the face will be new construction and the face filter will be show complete. Show complete. So that applies to all the other proposed elevations. Existing and demo would be new construction and show previous plus demo. Now, you go back to that proposed floor plan, right? So all these tags you see on the proposed floor plans are certainly only proposed elevations. Do you understand? All these, you remember we've hidden the existing before we pasted, right? So all these ones are certainly proposed. Now on the existing and demolition floor plan, we have both the tags for the existing and both the tags for the proposed elevations shown on that one. So the way to hide them from existing and demolition floor plan is to first select them from proposed floor plan and go to existing and demolition floor plan and then hide them from view. Right click, hide a view element. So that way we only have existing and demolition tags, elevation tags on existing and demolition floor plan. I hope that clarifies it.
Yes.
Okay. So it's just a matter of creating, so to review or recap the process. You first create all the tags, all the elevations on your existing and demolition floor plan. Then you select them and then you copy to clipboard. Then you go to your proposed floor plan and then hide from view those elevation tags. Then you now paste, you know, you're gonna paste the tags that you copied earlier to your proposed floor plan. So doing that, you will now be seeing two series of elevations on your project browser here. So those ones carrying 1 1 1 1 1 1, they are the proposed elevations. Those ones that do not carry 1 1 1 1, they are the existing and demolition. So make sure you of course must have renamed everything, set the phase filter accordingly, drag the levels so they envelop the building, change levels to halftone. Just do the normal graphical tweaks to each elevation. So that's how you achieve it. Electrical plants, I've gone over this, so apply the principles that you learned. Smoke detectors are not supposed to be, they are not supposed to be in your bathrooms. I said this in the bedrooms, not the bathrooms. So these ones should not be here, they should be in the bedrooms, not the bathrooms. And also, regardless of whether you are working on the bedrooms or not, you must always show smoke detectors for the bedrooms, regardless of whether your scope of work includes it or not. Another thing, you know that this should be GFI, right?
Yeah,
this should be GFI. You know that this should be in front here, not in that corner there. You know that this one, ideally, you want to have it usually one in shower and one maybe right in front of the WC. Just find a way to distribute it in a way that is logical. The recessed lighting,
pictures, right?
yes, the recessed lighting, yes. So this is GFI. Now you're going to have wall lamps too. Remember to have your wall lamps, all your switches, 3 switches controlling all 3 appliances. 1 switch controlling the recessed lighting, 1 switch controlling the exhaust fan, and 1 switch controlling the interior floor lamp. Also, you are going to light the living room. Now, the living room cannot possibly be left like this. So you are going to design the lighting for the living room. You are going to have a chandelier. I will share you a Kai electrical plan. So that will give you, I will give you insight into the symbols. You are going to be using the Kai approach for electrical plans going further. So I will share you a Kai project, and that's the basis. That should be the basis for your electrical plan. Don't use SLC approach for electrical plans. Use Kai approach.
For electrical plan.
Yes. For both Kai and SLC project, use Kai approach for electrical plans. Also apply the principles of what do you call it? Of how you should space your outlets, and this should all obviously be GFIs, right? So you should have have one next to the fridge, space them in the corners, near the sinks. Another area I forgot to mention is where you have islands, kitchen islands like this. You usually want to place GFIs on both ends. So this should be a GFI on both ends of the counter, and then you want to mirror it to the other end. So you want to place another one here, and it's also going to be GFI. Remember, here you want to place this to be 3 feet away from the wall. And if I were you, I won't be having 3 lights in here. I'll be having 2. So even how you place the point light it matters, right? How you place the point light matters. You don't just randomly position them. So if I were you, I would want to have 1, 2, 3. This is how, of course, they should be aligned. You are going to have grid lines to help you design the alignments. And I may even want to have one here. So I may want to have 3 here and 2 here.
Wait.
Okay, go on.
Complete arrangement. I'm trying to see arrangement.
Okay, just find a way to logically distribute them. You want to have pendant lights on the island, maybe 3 or 2 of them, depending on how large the island is. and of course you are going to be providing switches. If I were to design a switch here now, yeah, the lighting for the kitchen and the island, I will likely position them here as you've done. But I don't need these 3 light points you put here. Okay, I may leave this last one, but I don't need these 2. This last one will be designed. Okay, let me just do a sketch of how best we want to light this space. Let me just do a sketch for that. For how we want to design the electrical system. So you are going to remember to bear in mind your scope of work while you are designing it.
Yeah. Yeah.
So what I want to do is have points light sources 1, 2, 3, 4, 5. I want to have pendant lights here, about 3 of them.
Yeah.
I want to have my living area to have 3 columns and 2 rows of lighting. I want to have my chandelier right in the middle. Of course, the orientation will depend on your table, in the way you have your table. I want to have a switch. I want to have a switch here. I want to have a switch controlling this. I want to have another switch here. So this is a 2-way switch, are we? Remember 2-way switch is abbreviated 3.
Yeah.
I want to have an outdoor wall lamp here and a switch controlling that wall lamp I have on the outdoor. I want to have a kind of outlet.
How about the GFI outside?
What? Yeah, that's what I'm doing now. We are going to have GFI and waterproof, WP and GFI. Remember the orientation of the text should follow the direction of the fixture or the outlet. GFI slash GFI then WP. So for the kitchen switches, I'm going to have 2 of them. One for the recessed lighting in the kitchen. Another for the pendant lighting. Now even the chandelier needs its own switch. Is there anything I'm forgetting? Yes, remember the entry area is also part of our scope of work.
Yes.
So we are going to have a point light source here. We are going to have maybe a wall lamp somewhere, because we have full height glazing. Maybe we should have we can have the wall lamp here. Let's have the wall lamp here. So this is the outdoor wall lamp. Okay, we already have wall lamps in front of the columns in front. So this is where we want to have the wall lamps. We also have 2 in front of the garage. Because this is an exterior door, we need a waterproof and GFI outlet here. So let's use this. Okay. Now your bathroom, You want to have your exhaust duct, your exhaust fan rather. You want to have it here. You want to have your point light sources here. That's your recessed lighting. You want to have them here.
Yeah.
You want to have your GFIs. Okay, your GFIs can be to the side of this. This one can be to the side.
Okay.
Also, you need your wall lamp, your indoor wall lamp rather.
Yeah.
Check the appropriate symbol. And now you have 3 switches, 1, 2, 3, 1, 2, 3. I'm not going to draw the switches for the bathroom. Now you want to show smoke detectors.
Yeah.
You want to show smoke detectors here in the bedrooms. So use the right symbols for them. And when you do that, I think you've fully designed the electrical system. Of course, you need switches here. This is going to be, you need a switch controlling the outdoor wall lamps.
Pardon me.
I'm with you.
Pardon me, but can you hear me?
I'm with you.
Are we are we not supposed to do how am I making the manually the
Yes,
SD
vacancy sensor,
in the-
vacancy switch. Yes, of course.
Yeah?
You need a vacancy switch in the bathroom,
Yeah,
controlling
yeah,
the
yeah.
lighting. So you don't forget to use the right symbol, which is V.
Okay.
I said I was going to show
Yeah.
the symbol, but you need a vacancy sensor. What's it called? Switch
Okay.
in the bathroom. So with that, we have. I remember when you are indicating your outlets here, there will be GFCIs,
Yeah.
and the one for the cooker and the
Yeah.
refrigerator will be 240 volts.
Yeah.
So just make sure you recall that. So let me share this with you. Of course, you are going to design the outlets the way
Yeah.
they are supposed to be positioned. So, I guess now you have to now position the elevations, be mindful of the graphics, go over both Kai and SLC approach. But remember I said for elevations, we should stick
Yeah.
to Kai approach.
Yeah.
Then
Hi. Yeah.
SLC, we are going to, use the other, methods for other drawings. So
Yeah.
just do all of those, and then you will have a comprehensive drawing. Before you, I don't know, you already know a bit about the tags and what's it called? What have I not mentioned? Ventilation calculation. That's your attic vent
Yeah.
and your floor vent. But I won't be going through that now. I'm exhausted. So I'll record another video
Okay.
much later where I would be focusing
Yeah.
on vent calculation and
Yeah.
schedules. So for now, with this information you have, you should be able to improve the drawings you
Yeah. One day. And
Delivered.
drawing.
yeah. So
Uh,